The sky is on fire. Not from war, not from volcanoes, but from a rain of stars turned weapons, streaking across the firmament as oceans rise in walls of black water and whole continents vanish in a single night. Somewhere on a shrinking shore, a small band of survivors watches the world they knew die, clutching not gold or weapons, but stories. Tonight, on Moonlight Science, we follow those stories back to their source, to the night the last ice age ended, when a real 12,000-year flood carved itself into the bones of our planet and into the myths that still haunt us. This is the tale of a forgotten civilization standing on the edge of annihilation, the celestial crossfire that erased them, and the memory they smuggled into the future disguised as legends of gods, arcs, and world-ending deluges. And there is one last secret, buried not in ice or stone, but in us, a legacy from that night of fire and water that we still carry without remembering. Until now. To understand that night, we have to start in the calm before the storm. Imagine Earth 12,800 years ago. The world is colder, sharper, more austere than ours, yet strangely alive. Over the northern half of the planet, ice sheets sprawl like frozen continents, towering up to a mile high. Their flanks break into glittering cliffs, calving thunderous bergs into proglacial lakes the size of inland seas. South of the ice, a vast grassland stretches to the horizon. The mammoth steppe, the richest ecosystem the planet has ever known. Under a hard blue sky, herds of shaggy giants move like living hills across this open world. Woolly mammoths, mastodons, and giant bison graze in slow, deliberate waves. Saber-toothed cats stalk the margins, low to the ground, muscles rippling under spotted fur. Short-faced bears rear up like walking boulders. Everywhere, the air smells of cold earth, crushed grass, and distant snow. And among them, small, clever hunters move with a different purpose. Our ancestors. Wrapped in hides, faces hardened by wind and ice, they follow the great herds with spears tipped in carved stone. For them, the Ice Age is not an era. It is simply the world. The stars are steady. The seasons, though harsh, are predictable. Water, locked in ice, keeps sea levels low, exposing wide coastal plains where camps and settlements hug ancient shorelines now buried under modern oceans. For thousands of years, this balance holds. The great ice sheets, though beginning to melt back slowly, still seem eternal. Rivers run where they have always run. A child can grow up, hunt, love, and die under a sky that never hints how fragile it is. Then the countdown begins, though no one living then knows it. Somewhere far beyond the orbit of Mars, a massive, loosely bound comet has wandered for ages. Drawn inward by the sun's pull, it crosses the paths of the inner planets. Over many orbits, it begins to fragment, its icy nucleus cracking, shedding a trail of debris. A river of cosmic rubble that will one day be called the Taurid meteor stream. On one ordinary-seeming night, Earth drifts into the densest part of that invisible river. At first, it's beautiful. Bright streaks scratch across the sky, more than usual, like a meteor shower gone wild. Hunters pause, their fires crackling low, and look up. The elders squint, uneasy. The stars are in their places. The moon rides high. But something is wrong with the way the sky is moving. Then one of the streaks grows, brightens, blossoms into a silent sun. High above the Laurentide ice sheet, over what is now North America, a chunk of that ancient comet slams into the upper atmosphere at tens of kilometers per second. It does not hit the ground. The air itself becomes its impactor. In an instant, the object is crushed and vaporized, releasing energy comparable to the largest nuclear bombs we have ever built. A sphere of incandescent plasma blooms, brighter than day, then collapses downward in a supersonic shockwave. The sound arrives too late to be a warning. A wall of compressed air scythes across the ice, flattening everything in its path. Forests are shredded in an instant. Animals are hurled like leaves. On the surface of the ice sheet, the heat is beyond imagining. Snow and ancient compacted ice flash melt and vaporize, gouging out pits, carving funnels that will, millennia later, puzzle geologists. And that is only one fragment. Across a broad swath of the northern hemisphere, dozens, perhaps hundreds of similar airbursts detonate within minutes, some over ice, some over tundra, some above the ultra-dry low-S plains of Eurasia. The upper atmosphere fills with incandescent streaks and expanding fireballs. Where they erupt, entire forests ignite at once. Night is erased, replaced by a chaotic, flickering false dawn of bursting stars. For people on the ground, it is the end of the world. The first sign is the wind, a hot, impossible gale that smells of burning resin and scorched fur. Then comes fire from directions where no storm should be. The horizon glows a dull, sullen red as tree crowns catch like torches. Birds explode from the canopy, only to fall lifeless, stunned by the shock waves. Rivers steam, lakes shimmer as their surfaces flash heat, sending fog banks of superheated vapor rolling over nearby shores. Far to the north, on the ice shield, the real disaster is unfolding. Those instantaneous blasts of heat and pressure have opened wounds in the frozen colossus. Meltwater, trapped for centuries in hidden reservoirs within and beneath the ice, surges free. Dams of frozen rock and compacted snow collapse. Entire subglacial lakes burst out in titanic floods, roaring along the base of the ice sheet before erupting at its margins. From the perspective of someone camped near one of these outflows, the world simply starts moving. The ground trembles. A distant rumble grows into a continuous roar, like thunder that never stops. Animals flee past, their instincts screaming. Then, around the bend of a valley, a wall of churning, debris-choked water appears, higher than any wave, carrying trees, boulders, ice blocks the size of houses. There is no high ground fast enough. Elsewhere, where ice once held the oceans in check, the same heat pulse and structural collapse begin a more patient catastrophe. The vast, frozen reservoirs of Greenland and northern Europe start shedding meltwater at rates no human has ever seen. Glaciers slump and crack. Their termini retreat uphill in panicked jerks. The excess water pours into rivers, then into seas, raising shorelines, gnawing at coasts. Low-lying plains vanish over decades, in what, compared to human lives, feels like forever. But in geological terms is the blink of an eye. The atmosphere, loaded with soot from continent-spanning wildfires, darkens. Sunlight dims. Ash and vapor rise high, some reaching the stratosphere where they linger, reflecting heat back into space. The immediate firestorm gives way to a different kind of terror. A sudden, plunging cold. In ice cores drilled from Greenland, this entire sequence is compressed into a thin band of altered chemistry and trapped air. One moment, the world is warming predictably out of the last glacial maximum. The next, temperatures nosedive. Dust increases. Strange spikes of platinum, a metal common in cosmic objects, suddenly appear. To the scientists reading these frozen pages, the signal is unmistakable. Something violent happened, fast. But to the people beneath that bruised sky, there are no graphs, no isotopes, no models. There is only the memory of fire that fell like judgment, of flood that rose like a living thing, of winds that tore the breath from your chest and the trees from the earth. There is the taste of ash and the sound of animals screaming in the dark. there is the dawning realization that the world itself can break, and that realization will not die when they do. It will be carried, softened, and reshaped in words, in songs, in the first faint sketches of gods and monsters. One night of cosmic violence, stretched across generations, will become a single, unforgettable phrase. The flood. Those memories, at first, exist only in frightened eyes and trembling voices. But the planet itself keeps a different kind of record, one written not in words, but in ice. Far from the burning forests and roaring floods, at the summit of what we now call Greenland, snow fell as it always had. Flake upon flake, storm upon storm, winters stacked themselves into a pale, silent archive. Each year's snowfall buried the last, compressing it, squeezing out some of the air, but never all. Trapped between the crystals, tiny pockets of atmosphere were sealed away, perfect little time capsules of the sky that was. From orbit, Greenland looks like a featureless white shield. But beneath that smooth surface lies a towering column of memory more than 3 kilometers deep. Scientists reading that memory use a simple but audacious tool, a hollow drill slowly biting its way down through tens of thousands of years. From the surface, the core emerges as long, glassy cylinders, each segment a frozen chapter. To hold one is to literally touch the snow that fell when mammoths still walked. Laid out in a cold lab, those cylinders glow faintly blue. Under the right light, you can see the annual layers, faint bands of density, like growth rings in a tree. Some years are thick and clean, others thin and dust-laden, marked by distant volcanic eruptions or Saharan storms. Technicians slice the ice into samples no bigger than a finger, each one representing a specific moment in time, then melt them in sealed chambers to release the air trapped inside. That air is tested with extraordinary precision. The ratios of oxygen and hydrogen isotopes reveal temperature. Lighter isotopes evaporate and condense differently, so a colder world leaves a distinct signature. Plot those ratios against depth, and you get a climate graph stretching back over 100,000 years, a heartbeat line of the Ice Age. For most of that span, the heartbeat is jagged but comprehensible. Temperatures rise and fall over centuries, millennia. Glacial cycles pulse in slow, stately arcs. Then, around 12,800 years ago, the line suddenly plunges. In some cores, the inferred temperature at Greenland drops by as much as 10 to 15 degrees Celsius in a matter of decades, perhaps even less. On a human timescale, that's the difference between a rainy autumn and permanent permafrost. It is as if someone reached over and yanked the planet's thermostat from thaw back to deep freeze almost overnight. But temperature is only part of the story. When scientists look at the same depth for other clues, they find more ghosts. Dust concentrations spike sharply. This suggests stronger winds whipping across newly exposed, vegetation-stripped ground. The world, suddenly colder and drier, begins to shed its topsoil into the air. Combined with this, levels of tiny charcoal fragments surge, evidence of widespread wildfires just before or during the transition. The image that emerges is of a planet roasting, then freezing, a 1-2 punch of fire and cold. Then comes a stranger signal. Platinum, in several independent cores and in layers of sediment across North America and Europe. Researchers find anomalously high concentrations of this rare metal precisely at the Younger Dryas boundary. On Earth's surface, platinum is scarce. In certain types of asteroids and comets, it is common. Its sudden global appearance in that thin slice of ice hints at something not of this world. Magnified further, the ice reveals microscopic particles, magnetic spherules, tiny glassy droplets. that look suspiciously like material melted and splashed into the air, then cooled mid-flight. Some have compositions consistent with impact-heated crust and extraterrestrial dust mixed together. These are not the products of a quiet climate shift. They are the signature of violence. To reconstruct the moment the Younger Dryas begins, you have to stack these clues like translucent slides. Temperature crashing, dust surging, soot rising, platinum spiking, strange melt products appearing. Individually, each could have alternate explanations. Together, converging at the same depth, they sketch a single, stark conclusion. Something hit us. Or rather, many somethings. Not every scientist agrees. The impact hypothesis has faced fierce scrutiny, as it should. Critics argue about contamination, about alternative volcanic sources, about the interpretation of nanodiamonds and spherules. Ice, after all, is delicate evidence. Yet as new cores are drilled, from different sites, by teams with no stake in the controversy, the same peculiar fingerprints keep turning up at the same time. In a way, the argument itself is a sign of how far we've come. Our ancestors watched the sky burn and heard no explanation but the anger of gods. We, millennia later, take pinches of ancient snow and ask the bubbles to testify. In their chemistry, in their faint traces of ash and metal, we hear an echo of that night when the world flinched. Stand for a moment in imagination, inside the ice. Above you, as the Younger Dryas begins, the surface is a chaos of storms and fire. But down in the layers already laid, everything is still. Snowflakes drift, settle, and are buried. Time presses them into ice, and with them, the breath of animals, the exhalations of forests, the aerosols of burning continents. In one such layer, air from a year of terror is locked away. Thousands of years later, a drill will bite into it. A scientist will lean over a mass spectrometer. A line on a screen will jump. The data is just numbers, cool and clinical. Yet what those numbers describe is anything but abstract. They record a world tipping from warmth back into lethal cold in a single human lifetime. For the survivors on the ground, that flip meant hunger, migration, extinction. For us, it means something else. A warning, coded into ice, that the planet we take for granted can change state with terrifying speed. And that somewhere out there, the agents of that change still orbit, silent, waiting for their next appointment with our fragile world. The ice remembers in chemistry and trapped air. The ground remembers in scars. Far from the sterile brightness of ice core labs, under open skies and buzzing field camps, archaeologists kneel in dust and mud, knife blades tracing the slow curve of time down a trench wall. At first glance, what they uncover looks unremarkable. Bands of earth in shades of tan, rust and gray. Each layer, a chapter of local history laid down over thousands of years. But then, at sites scattered across North America, Europe, even the Middle East, something else appears. A line. Thin, dark, unmistakable. They call it the Black Mat. In New Mexico's Murray Springs, the desert wind whistles over shallow gullies as trowels carefully shave back sediment. A technician runs a brush along the exposed profile, and there it is. A narrow, inky stripe, just a few centimeters thick, stretching unbroken across the wall. Beneath it lie the remains of an older world. Mammoth bones stained brown by age, Clovis spear points lying where they fell, scatters of butchered bison. Above it, the story changes. The giants are gone. The tools are different. The people, if present at all, have moved on. The same pattern repeats at site after site. In Arizona, in South Carolina, in Canada, In Syria and along the banks of ancient rivers in the Levant, archaeologists see it again. A sudden, dark horizon that divides before from after. Radiocarbon dates from materials immediately above and below that band cluster around the same time the ice cores scream their warning, roughly 12,800 years ago. Up close, the black mat is not uniform. In some places, it is a greasy, organic layer rich in decayed plant matter, like the residue of a long-vanished marsh. In others, it is packed with tiny charcoal fragments, as if 100 forest fires had sifted their ashes onto the land and rain had pressed them into a thin, coalesced veil. To the naked eye, it says one thing clearly. Something burned, widely and intensely. But under microscopes and in geochemical labs, the black mat begins to whisper a more complicated story. Grains of soil, mounted on slides, reveal countless fragments of charcoal, angular and glossy. Their cell structures are sometimes still visible, tiny blackened ghosts of grasses, shrubs, trees. Many are vitrified, glassy, suggesting they formed at extraordinarily high temperatures. Intermixed with them, researchers find spheroids, tiny, perfectly rounded droplets of once molten material, often magnetic. These spherules have compositions that look like melted terrestrial rock fused with something else, something enriched in elements like nickel and iridium. In some samples, scientists detect nanodiamonds, crystals so small they cannot be resolved with ordinary microscopes. These can form under conditions of extreme pressure and temperature, like those produced in high-energy impacts or powerful airbursts. And, as in the ice, they find anomalous enrichments of platinum, that rare cosmic fingerprint, right at the base of the black mat. Taken together, these clues point toward a sequence of events that matches the narrative frozen in Greenland, but now seen from the ground's point of view. First, fire. If a swarm of comet fragments exploded over multiple continents, each airburst would have radiated intense heat over enormous areas in seconds. Dry vegetation, already stressed by a warming climate at the end of the Ice Age, would have flashed into flame. In forests, crowns would have ignited simultaneously, creating firestorms incapable of being outrun. Grasslands would have burned like paper. The charcoal. Fragments in the black mat are the residue of this planetary inferno. The vitrified pieces and certain spherules suggest not ordinary wildfires, but temperatures higher than even the fiercest natural blazes typically reach, perhaps amplified by direct radiant heating from above. Then, fallout. The magnetic spherules and nanodiamonds are like tiny meteorites' death masks, droplets of rock and cometary material melted and splashed into the sky, then raining back down to settle on soils, lakes, ice caps. In the days and weeks after the explosions, a fine, dark dust would have sifted out of the troubled air, coating everything with a thin, grim snowfall of burned and altered matter. Where that fallout landed on wetlands or low-lying areas, the story becomes strangely quiet. The black mat in many regions has a greasy, algal character, organic, water-rich. It appears that after the fires, in a newly cooled climate, marshes spread. Stagnant, shallow waters collected in basins left by floods and glacial melt, fostering mats of algae and moss. Over centuries, this living carpet grew, died, and compacted, forming a dark, organic seal over the bones and artifacts of the Pleistocene world. That seal is what archaeologists now slice through. On one side, the remains of Clovis hunters and Pleistocene megafauna. On the other, a conspicuous absence. The large animals that once dominated the continent, mammoths, mastodons, giant ground sloths, American lions, do not reappear above the black mat. Their tracks end at that horizon, as if they walked to the edge of a page and fell off the story. The people, too, are affected. Below the mat, stone tools of the Clovis culture are widespread, recognizable by their elegant, fluted spear points. Above, those artifacts vanish or transform, replaced by different styles and technologies. Some groups may have died with their prey. Others adapted, shifted diets, moved into refugia, where the impact of the catastrophes was less severe. Archaeology records this not as screams in desperation, but as abrupt changes in debris. It is tempting to think of the black mat as a crime scene outline drawn around a dead body. In a sense, it is. That dark band is Earth's burned scar, stretched across continents, a forensic boundary between the age of ice and giants, and the leaner, harsher world that followed. Within its few centimeters of soot, glass, and algae lies a compressed record of the greatest ecological break in the last 100,000 years. When excavators peel it back, they are not just uncovering dirt. They are lifting the scab on a wound our planet still remembers, revealing the moment when an almost unimaginably stable world was kicked into a new state by a storm that fell not from clouds, but from the stars. Long before anyone dug into the black mat or melted ancient ice for clues, the first evidence of the cataclysm lay exposed on open ground. Bones. Enormous, weather-whitened, sometimes still locked in the positions their owners died in. To understand what was lost when the world burned and froze, we have to walk for a moment among those vanished giants while they still breathed. Picture the mammoth steppe at its full glory. A cold wind combs through knee-high grasses that ripple like a silver sea under a low sun. On the horizon, a herd of woolly mammoths advances, slow and implacable. Their silhouettes are mountainous, massive shoulders swaying, curved ivory tusks tracing pale arcs above the snow. Steam billows from their trunks with each breath. Calves trot between the legs of their mothers, occasionally bumping playfully against one another before being herded back into the protective wall of adults. Nearby, a mastodon browses in a stand of conifers, its shorter, straighter tusks levering branches down within reach of its trunk. Unlike its grass-eating mammoth cousins, it prefers leaves, twigs, the gritty crunch of bark. Its bulk is staggering. 6-7 tons of living muscle and memory, its skin crisscrossed with scars from ancient fights and close calls. When it moves, saplings simply bend out of its way. Under the trees at the edge of this open world, other shadows prowl. A saber-toothed cat melts between patches of light, its tawny coat patterned to break its outline. When it pauses, its head seems almost too large for its body, jaws thick and powerful to anchor those ridiculous, beautiful, deadly canines. They are more than teeth. They are weapons evolved for a particular style of killing, fast, deep, precise. A single well-placed bite to the throat of a bison, and the fight is over. On the slopes beyond, a giant ground sloth rears up, towering over shrubs and small trees. Its claws, long and curved, look like tools of a predator, but they are mostly for raking down vegetation. Still, woe to anything that threatens it. A swipe from those limbs could disembowel a careless attacker. Its fur is long, matted with dust and bits of dried leaves. Birds may nest in it. Parasites certainly do. This world thrums with other improbable beings. Horses with thick winter coats, camels adapted not to dunes, but to snowfields, armadillos the size of Volkswagens, pronghorn antelope that can outrun any predator that now exists because they evolved fleeing faster hunters that no longer do. At the top of the scavenger hierarchy prowled dire wolves and short-faced bears, creatures so large and powerfully built that even a modern grizzly would seem modest beside them. into this bestiary steppe humans. Compared to these animals, we are fragile. No tusks, no fangs, no claws worth mentioning. But we carry something else. A growing arsenal of stone weapons and a dangerous collective intelligence. We organize hunts, drive mammoths into bogs, and bring down animals many times our size with coordinated strikes and exquisitely crafted spear points. For thousands of years, we coexist with the megafauna in a tense balance. They are our prey, warshai competition, and the architects of the ecosystems we inhabit. Then, as the black mat and the ice cores both attest, something breaks. In geological terms, the extinction is instantaneous. Below the Younger Dryas boundary, fossils of these giants are abundant. Above it, they thin, then vanish. In many regions, more than 3/4 of large mammal species disappear within a few centuries. On human timescales, that is not a slow fading. It is your grandparents telling stories of animals you will never see, and your own children regarding those tales as myth. For decades, two main culprits have vied for blame. One is us. The overkill hypothesis proposes that as human hunting techniques improved and populations spread, we simply ate our way through the megafauna. Clovis points lodged in mammoth ribs provide visceral support. We certainly killed some of them. The second suspect is climate. As the Ice Age waned, habitats shifted. The mammoth steppe fragmented into forests and wetlands. Some species, exquisitely adapted to cold, open ground, may have failed to adapt. Both stories fit part of the data. Neither, alone, fully explains the brutality of the cutoff. Layered on top of them now is a darker possibility that many of these creatures did not die slowly at the edge of change, but abruptly, in fire and flood and poisoned lungs. If a rain of comet fragments ignited continental wildfires, as the black mat suggests, entire herds could have been trapped in advancing walls of flame or suffocated as superheated air fronted shock waves. Those near coasts or ice-fed rivers would have faced another fate. Flash floods as meltwater reservoirs failed. Imagine a mammoth herd grazing in a familiar valley when the first tremor rolls underfoot, followed minutes later by a moving wall of churning mud, ice, and uprooted trees. Even those that survived the initial onslaught would have awakened to a transformed world. Burned grazing lands, ash-choked water sources, darkened skies. Soot and dust in the atmosphere reduce plant growth. Cold snaps decimate calves and young. Predators, desperate, push closer to human camps. Diseases may spread more easily as stressed populations cluster in shrinking refuges. Extinction here is not just a tally of vanished species. It is a cascade. Remove mammoths, and grasses behave differently. Woody shrubs encroach, changing fire regimes and water cycles. Without giant browsers, forests thicken or thin in new ways. Scavengers that once fed on titanic carcasses must adapt or die. Human cultures built around megafauna hunting are forced to reinvent themselves. New tools, new prey, new stories to explain why the old animals are gone. For the people who lived through it, the loss would have been existential. Imagine being a child of the mammoth age, then reaching adulthood in a world stripped of its titans. The horizon feels emptier. The winters, harsher without herds to follow. The old trails mean nothing. You would not need a scientist to tell you the world had ended. You would feel it every time you stepped outside and saw only space where giants used to stand. Those feelings, grief, bewilderment, a sense of cosmic betrayal, do not fossilize like bones. But they can seep into the stories told around new, smaller fires. They can become whispers that the great beasts angered the sky, or that the gods, displeased, took back their animals. Over time, these whispers fuse with memories of fire from above and water from below, hardening into the first myths of a time before, when the monsters walked, and a time after, when they were gone. For the people who watched the last mammoths crumble into legend, the cause of their disappearance was wrapped in story. Angered gods, restless heavens, sins washed clean by a flood. For us, the suspect is stranger and colder, an intruder from the deep, a comet we never saw. When most of us imagine cosmic disaster, we picture a single cinematic impact. A dinosaur killer, one mountain-sized rock slamming into the ocean or land, throwing up a worldwide shroud of dust and vapor. It leaves behind a crater so vast it can be seen from space. We have such a scar. The Chicxulub crater in Mexico, the smoking gun of the dinosaur extinction 66 million years ago. But at the dawn of the Younger Dryas, there is no obvious Chicxulub. No fresh, neat bowl stamped into the crust right at 12,800 years ago that shouts, "Here, it happened here." Instead, we find a subtler pattern. Platinum spikes, nano diamonds, melt droplets, black mats, and an abrupt climate crash. To reconcile this evidence, scientists have turned their attention to a different kind of visitor. A giant, loosely bound comet. Unlike dense, rocky asteroids, many comets are dirty snowballs, porous agglomerations of ice, dust, and rock that have spent most of their existence in the deep freeze of the outer solar system. When their orbits are perturbed by passing stars, by subtle gravitational nudges, they can be drawn inward toward the sun. As they approach, solar heat begins to boil off their ices, releasing gas and dust that trail behind them as a glowing tail. But this outgassing can also destabilize the comet itself. Jets of vapor act like thrusters, spinning and torquing the nucleus, slowly tearing it apart. Astronomers have watched this happen in real time. Comets like Shoemaker-Levy 9, which fragmented into a string of pieces before slamming into Jupiter in 1994. Others have simply come apart near the sun, disintegrating into swarms of smaller chunks. Now imagine such a comet, originally tens of kilometers across, breaking into 1,000 pieces on a path that crosses Earth's orbit. In this scenario, Earth doesn't collide with a single, coherent body. It plows through a cloud of debris, sweeping up fragments ranging from boulder size to house size and beyond. Each one, individually, is far smaller than a dinosaur killer. But at cosmic velocities, 20, 30, even 40 kilometers per second, they carry immense kinetic energy. A chunk only 50 meters across can unleash a blast comparable to a large nuclear weapon if it explodes in the atmosphere. We have a modern example. Tunguska, 1908. Over the Siberian taiga, in the early morning hours, a small object, likely a stony asteroid or comet fragment, entered the atmosphere and detonated at an altitude of several kilometers. The explosion flattened over 2,000 square kilometers of forest, toppling trees like matchsticks. Witnesses described a sky split in two, a column of fire rising, shockwaves that shattered windows hundreds of kilometers away. Yet when expeditions finally reached ground zero, they found no crater. The object had never hit the ground. It had been destroyed by the very air it plunged into. Scale that up. Instead of one Tunguska, imagine dozens, perhaps hundreds, scattered over the northern hemisphere in the space of hours. Some detonate over ice sheets, some over forests, some over shallow seas. Each airburst carves a temporary bubble of incandescent plasma in the sky, radiating heat downward like a broiler. On the surface, the effect is not a single towering tidal wave from an impact point, but widespread ignition and patchwork devastation. trees exploding into flame, animals and people scorched or hurled by shock waves, ice melting explosively at the point of impact and in the subsurface where energy is conducted downward. Because many of these fragments disintegrate high in the atmosphere, they leave behind no classic, easily mapped impact structures. Instead, they spread a thin rain of melt droplets and exotic minerals over huge areas. The atmosphere, loaded with their vaporized remains and with the smoke from the fires they start, circulates those particles around the globe. Platinum and other cosmic markers drift down onto Greenland's ice, onto North American floodplains, onto Middle Eastern river valleys, forming the thin, telltale layers we now sample with drills and trowels. From the ground that night, it would not have felt like a single blow. It would have felt like the sky coming apart. Imagine standing in darkness on the Ice Age steppe. You are used to stars, eternal, cold, reassuring pinpoints. Perhaps you have seen meteors before, brief scratches of light that evoke awe, not fear. But this is different. The first streak is bigger, brighter, leaving a glowing train that persists. Then another. Then dozens. The constellations vanish behind a lattice of fire. One streak blossoms into a ball of white-blue light, swelling in an instant until shadows sharpen at your feet as if a second sun has risen in the wrong part of the sky. There is a breathless silence, the shock wave racing ahead of sound. Then the air slams into you, a physical blow. The ground heaves. In the distance, a mushroom of smoke and dust bulges upward, lit from within by lightning. To one horizon, forests flicker as if a giant had dragged a torch along their crowns. Above other lands, over the domes of ancient ice, similar suns are blooming. To an observer in orbit, Earth's night side would look like a battlefield, pock-marked with expanding circles of light and shadow. But there are no generals here, no armies, only physics, gravity, momentum. Computer models of such swarms suggest that even if only a fraction of the fragments are large enough to produce Tunguska-scale blasts, the cumulative energy dumped into the atmosphere, ice, and oceans could rival or surpass that of a single, large impact. The effects, spread over continents, might be even more ecologically disruptive. Fires in many biomes, meltwater pulses from multiple ice sheets, dust and aerosols injected into strategic layers of the atmosphere. So the absence of a tidy crater does not exonerate the sky. It simply points us toward a quieter assassin. A fragmented, fragile comet that did its work not with one theatrical blow, but with a storm of lesser strikes, each one brief, each one lethal, together sufficient to twist the planet's climate, erase entire species, and plant in human memory the indelible image of a night when the stars themselves turned against us. The night the sky turned to fire was only the opening act. The deeper catastrophe crept in afterward, silent, invisible, carried not by flames, but by water and wind. As the comet fragments tore through the atmosphere, they did more than ignite forests and flatten herds. Over the great ice sheets of North America and Northern Europe, their energy bit deep, cracking, melting, destabilizing. The immediate result was chaos at the margins. Sudden outbursts of meltwater, rivers rising in frenzies, lakes failing catastrophically. The delayed result would be stranger. A world that, after briefly roasting, slipped abruptly back toward an ice age. Before the cataclysm, the planet had been warming. For several thousand years after the peak of the last glacial maximum, temperatures had been rising, glaciers retreating in fits and starts. Shorelines crept inland, revealing new rivers and wetlands. Forests began advancing into territory long held by tundra and steppe. For our ancestors, this meant more plants, more animals, more opportunities. The direction of travel seemed clear, away from ice toward a kinder climate. Then, in the wake of the impacts, something in Earth's great plumbing failed. At the time, a colossal ice sheet, the Laurentide, still smothered much of North America. To its south, vast proglacial lakes pooled along its rim, trapped behind frozen dams of ice and earth. Lakes like Agassiz and Ojibwe held more fresh water than all of the modern Great Lakes combined. The shock of the airbursts and the subsequent structural weakening of the ice likely pried open new channels, carving tunnels under the glacier, fracturing its margins. Once a path to the sea opened, water that had been held back for centuries or millennia could escape in a matter of months or days. Imagine one of those meltwater giants abruptly finding a way out. Perhaps through what is now Hudson Bay, perhaps through the St. Lawrence, perhaps both at different times. A torrent of frigid fresh water, carrying chunks of ice and rock, roars downhill, pouring into the North Atlantic. This is not a flood you can see from one valley. It is an oceanic event, a massive pulse of low salinity water spreading across the surface of the sea. Under normal conditions, the Atlantic is driven by a powerful conveyor belt known as the thermohaline circulation. Warm, salty water flows northward from the tropics along the surface, releasing heat into the atmosphere and moderating the climate of Europe and eastern North America. As it cools and becomes denser, it sinks in the high latitudes and flows back southward at depth, completing the loop. It is this engine that keeps, for example, Britain far milder than other places at the same latitude. Dump enough cold, fresh water into the North Atlantic, and you tamper with that engine. Fresh water is less dense than salty water. Spread a thick lens of it over the ocean's surface, and you hinder the sinking of cooled surface waters. It's as if you've thrown a blanket over the conveyor's intake. Models and evidence suggest that after the Younger Dryas onset, this circulation slowed drastically or even stalled. The results would have been dramatic. Without the northward flow of warm water, the North Atlantic region loses a major source of heat. Winters lengthen and bite harder. Sea ice extends further south. Storm tracks shift. Meanwhile, heat that would have been exported north remains in lower latitudes, potentially intensifying droughts and heat waves elsewhere. The planet does not simply get colder. It redistributes its warmth in a new, harsh pattern. We see the fingerprints of this shift in the mute testimony of mud and pollen. In lake beds across Europe and North America, cores tell a story parallel to the ice. Just before the Younger Dryas, pollen grains from trees, birch, pine, later hazel and oak, begin to dominate the microscopic record, reflecting forest expansion in a warming climate. Then, at the boundary, arboreal pollen plummets, replaced by grains from grasses and cold-tolerant shrubs. In some places, pollen from alpine and Arctic species appears at much lower elevations and latitudes than today, signaling a sudden ecological rewind. Forests die back or cling to scattered refuges. Open, tundra-like vegetation reclaims the land. Sediments change character as well. In some lakes, layers from this period are rich in wind-blown dust, implying drier conditions and exposed soils. In others, increased coarse material suggests intensified erosion from more violent storms or disrupted vegetation cover. Shorelines along coasts and inland seas bear the marks of fluctuating water levels as changing precipitation patterns and meltwater pulses play havoc with hydrology. In the Levant, where early humans were experimenting with proto-agriculture, evidence points to a sudden cold, dry snap at the start of the Younger Dryas. The Natufian culture, which had begun to settle around abundant wild cereals, seems to have been pushed back toward more mobile hunting and gathering lifestyles as their semi-sedentary niches withered. In Europe, human sites thin or shift. In some regions, people apparently retreat southward or cluster in more hospitable microclimates. Globally, the Younger Dryas lasted about 200 years, roughly the span from the fall of the Western Roman Empire to our present day. Long on a human scale, shockingly brief in geological terms. To a child born in its first decades, the stories of fire from the sky and sudden floods would already sound like something from the old time, perhaps exaggerated by fearful grandparents. To that same person's grandchildren, the dominant reality would be the world after. Longer winters, shorter growing seasons, harsher winds across a more treeless land. Yet even within that cold interval, change did not pause. Ice sheets continued to shrink overall, though with regional fits and starts. Sea levels, punctuated by sudden jumps, kept inching upward. Then, as abruptly as it began, the Younger Dryas ended around 11,600 years ago. Greenland's temperature, as read in the ice, shot up again in decades. Pollen records flip back toward forest. Dust levels drop. The Atlantic conveyor seems to restart. To those alive then, it must have felt like whiplash. Grandparents recalling a gentler warming world. Parents recounting nights of fire and the onset of bitter cold. Children suddenly sensing springs lengthen and summers grow kinder. For us, looking back through data, the Younger Dryas stands as proof of a stark reality. Earth's climate system is capable of flipping between very different states with terrifying speed, triggered by events that begin far beyond the comfortable shell of our atmosphere. The Younger Dryas was born in fire and settled into cold. But between those two states ran something far more tangible: water. Not the familiar, domesticated rivers that farmers later would name and tame, but sudden, roaring monsters. Floods so large they defy our ordinary sense of scale. To see what they did, we have to walk across the landscapes they left behind, in places where the ground still remembers being scraped raw by moving oceans. In the dry country of eastern Washington state, the hills are wrong. From the air, they look like frozen waves. Long, streamlined ridges of gravel and rock called drumlins, all pointing in the same direction. Between them lie broad, flat-bottomed channels, coulees, with walls of basalt rising like cliffs. Some are utterly dry, ending abruptly against higher ground, as if someone began to carve a canyon and then changed their mind. On valley floors, you can find giant ripples, undulating ridges of sediment so large that each wave is the size of a house, spaced like swell on a petrified sea. For years, geologists argued about how such features formed. Ordinary rivers, even swollen in seasonal floods, couldn't do it. The channels are too big, the boulders too enormous, the ripples too vast. It took a man named J. Harlan Bretz in the 1920s to suggest something that sounded outrageous. These were the scars of truly colossal floods, events so extreme they had no modern analog. Bretz was ridiculed. Catastrophes of that magnitude smacked of biblical deluge, not sober, gradualistic science. But as more evidence came in, giant current ripples, huge erratic boulders stranded far from any source, dry cataracts and plunge pools hundreds of meters wide. The case became impossible to ignore. The region had indeed been swept, multiple times, by flows of water hundreds of meters deep, racing at speeds approaching modern airplanes. Today we know the source: Glacial Lake Missoula, a proglacial lake that once pooled against the southern edge of the Cordilleran ice sheet, dammed by ice that crept down from Canada into what is now northern Montana and Idaho. That ice dam, hundreds of meters high, held back as much water as some of the world's great modern lakes combined. When it failed, as ice dams inevitably do, it did not simply leak. Imagine standing somewhere near that dam in the final hours. Up valley, a vast inland sea presses against a wall of frozen blue and white. Cracks thread the ice, dark lines spreading like the veins of a leaf. Meltwater seeps, then jets, then roars through hidden tunnels. The lake's surface begins to drop, slowly at first, then faster, as more of the dam's interior is eaten out. Finally, the structure loses cohesion. A section collapses. In minutes, a narrow torrent becomes a moving wall of water. The flood wave surges down the valley, entraining ice blocks, trees, whole chunks of shore. At its front, the water boils and foams, grinding bedrock into slurry. In constricted passages, it deepens and accelerates, reaching speeds of 50, 60, perhaps 80 kilometers per hour. Where the valley widens, it spreads, but remains unimaginably deep. In some reconstructions, the Missoula floods reached heights of 200 meters or more, enough to drown skyscrapers. As that water exploded out onto the Columbia Plateau, it attacked the basalt bedrock like a liquid glacier with a murderously short attention span. It plucked columns from cliffs, carved potholes large enough to hold houses, scooped entire coulees out of solid rock. Boulders weighing tens or hundreds of tons were rolled, lifted and left like abandoned toys when the water finally receded. Repeated many times over several thousand years, these Göbekli, glacial outburst floods, reshaped an entire region. And it wasn't just here. Across what is now the upper Midwest, other proglacial lakes, Agassiz, Ojibwe, pooled against the retreating Laurentide ice sheet. Their sudden drainages, whether east into the Atlantic, north into the Arctic, or south into the Mississippi Basin, would have produced their own megafloods, gouging spillways, rearranging drainage patterns, dumping fresh water into the oceans in violent pulses. In Europe, evidence suggests similar events from lakes dammed against the Scandinavian ice sheet, their outbursts scouring channels and depositing strange sedimentary packages far downstream. Picture what it meant to be downstream from one of these failures. You live in a valley carved by ice, now bright with summer growth. A river threads through it, cold and predictable, feeding marshes and stands of willow. You have camped here for generations, following migrating herds, fishing the shallows, knowing the bends of the water by heart. The glacier up valley is a distant, looming presence, white against the sky. But it has always been there. It is part of the scenery. Then, one day, a low rumble begins, a sound like far-off thunder that does not fade. Birds explode from the trees, flying against the direction of the noise. Animals you have never seen in this valley before, elk, wolves, even bears, come barreling past in a direction that makes no sense, eyes rolling, tongues lolling with panic. The ground trembles. The river at your feet begins to swell, not gradually, but with impossible speed, as if some invisible hand has tipped a basin upstream. Around the bend, where the valley narrows, a line appears. A roiling gray-brown front that grows taller as you watch. It is not a wave in any oceanic sense. It is the river itself, multiplied 100-fold, its surface choked with trees, ice blocks, pieces of shore. Above the liquid chaos, patches of white gleam, the broken faces of icebergs calved from the collapsing dam. The air ahead of it smells of silt and ancient cold. There is nowhere to run. The slopes are steep. The flood outruns your sprint before you reach the first ledge. Those who do gain height watch in stunned silence as their entire world, camps, hunting grounds, sacred places, vanishes under a moving sheet of grinding water, their familiar river valley transformed in an hour into a foaming canal. When the water finally drains away days or weeks later, the valley is not the same. The river has a new course. The old bends are strangled with coarse, alien gravel. Forests are gone, soils stripped, boulders the size of houses dot the floodplain in patterns that make no intuitive sense. To the survivors, it is as if a god took the landscape in both hands, shook it, and put it back down wrong. In our time, we read that violence in static forms, in scablands and stranded erratics, in giant ripples that only reveal themselves from the sky. Connected with the timing of cosmic impacts and the onset of the Younger Dryas, these megafloods become more than regional curiosities. They are the hydrological fists behind the mythic idea of a world-drowning deluge, not metaphorical, not theological, but literal walls of water let loose when a broken ice cap finally, catastrophically, let go. The land bears the gouges of ice and flood, the sky keeps faint chemical ghosts of fire. But the sharpest edge of the catastrophe cuts through people. All these forces, comet fragments, megafloods, sudden winter, are abstractions until you see them from inside a human life, measured not in millennia, but in breaths and footsteps. Across the mammoth steppe, families who had followed the same herds along the same routes for generations wake to a world out of rhythm. The first sign is scarcity. The big animals, once so predictable in their migrations, begin to falter. Calves die more often, herds split and thin. Hunts that were once almost a ritual, a known crossing, a favored ambush site, turn into desperate gambles. A week with no kill, then two. Children's faces sharpen, bellies flatten. Then come the nights when sleep will not hold. Smoke on the wind, at first a distant tang, becomes a choking presence. The sky at sunset deepens into a color no one recognizes, a bruised red that lingers long after the sun has vanished. Old people murmur uneasy comparisons. It looks like a wound, like meat searing on coals. Eventually, the fire itself arrives. Not the contained, creeping burn of a natural forest fire, but a crown of flame racing through the treetops faster than a man can run. Those who live near the margins of the ice watch their familiar white horizon fracture and slump. The great wall that had always anchored the world starts to move, groaning, cracking. Rivers that once trickled clear turn, turbid and wild, then reverse direction under the pressure of incoming floodwaters. Camps pitched on what was safe, high ground, are suddenly islands. Tents and belongings, years of carefully acquired tools and treasures, are left behind in the panicked scramble for something higher, drier, safer, which, in these moments, may not exist. Along ancient coasts, now long since drowned, fishing communities face a slower but no less terrifying threat. The sea is their partner, sometimes generous, sometimes moody, but always confined to its shore. Yet in the generations after the impacts, that shoreline becomes a traitor. The water creeps inland, not as a single apocalyptic wave, but as an inexorable, year-on-year theft. Campsites once comfortably above the tide line flood at certain moons. The elders insist the markers were right, that the sea has never come this far before. Shelters are moved back, then back again. Over a lifetime, favorite inlets become tidal channels, coves become bays. The security of place, of knowing where the land ends and the water begins, dissolves. Some groups manage to outrun the worst of it, slipping into refugia, regions where geography blunts the full force of cold and flood. Sheltered valleys with stable springs, south-facing slopes that catch winter sunlight. River confluences where fish still run. Others are less fortunate, their numbers shaved by one blow after another. A particularly brutal winter here, a failed migration there, a disease that rips through a weakened camp. Archaeologists see this in the record not as screams, but as absences. Sites abruptly abandoned, tool traditions breaking, long quiet gaps between layers. Geneticists, reading our DNA like another kind of sediment core, find similar hints. Certain lineages constrict sharply in this window of time, suggesting that some populations dwindled to a few surviving families before regrowing. These bottlenecks don't mean humanity almost went extinct. We were too widespread even then. But they point to real, localized catastrophes. Valleys and regions where, for a while, everyone you knew could fit around a single fire. Imagine greeting dawn in such a camp. The night has been restless. Winds howling, strange lights flickering on the horizon, the ground occasionally shivering under you like an animal shaking off flies. You step out into brittle air, each breath stabbing your lungs. The first thing you do is count. Not numbers in our abstract sense, but faces. Your sister, your children, the old man who can still make perfect spear points despite his twisted hands. The hollow in your stomach doesn't ease until you've ticked off each one. But some mornings, someone is missing. A hunter taken by a freak avalanche on the new, unstable slopes where ice has melted away. A child who coughed through the night and then simply stopped. A grandmother who lay down by the embers and did not rise. Grief becomes not an occasional interruption, but a constant undercurrent, the background radiation of life on a wounded planet. And yet, amid terror, people do what we have always done. We adapt, and we talk. New tools appear, harpoons for richer fishing in rivers swollen with glacial melt, nets woven to catch smaller, more prolific prey when the giants are gone. Clothing changes, shelters change, social arrangements shift. Some bands merging for protection, others splintering in search of unspoiled ground. Children are taught different skills, less about stalking mammoths, more about reading tricky currents or coaxing edible roots from stingy soils. Around the fires, when there is enough wood and calm to light one, words begin to organize the chaos. At first it's raw recollection. I saw the sky catch fire. The river climbed the mountain. The winter came back. These are not yet myths. They are testimony. But as years pass, as the original witnesses age and die, the stories pass with them. Trimmed here, embellished there, always orbiting the same incomprehensible core. The world changed in a way that felt like intention. Children ask why. Why did the sky do that? Why did the water eat our homes? Why did the great animals leave? No one can point to orbital mechanics or ocean circulation. They can only point up to the cold stars, or down to the restless earth, and give those forces names. Names with tempers and preferences, with angers that can perhaps be soothed or avoided. Out of hunger and fear and the need to make sense, narrative takes shape. Some will harden into law and ritual. Others will become the skeletal framework for the great flood stories, the doomsday cycles, the tales of lost ages and wrathful heavens that echo in altered forms across the world's later civilizations. In the crack between a stable past and an uncertain future, humanity discovers a new survival tool. Not just the spear or the shelter, but the story, our way of binding terror into something we can carry. When your world has been overturned by forces too vast to grasp, explanation is not a luxury. It is a necessity. The survivors of the Younger Dryas catastrophes had no spectrometers, no ice cores, no orbital mechanics. They had only what humans have always carried: memory, imagination, and a desperate need to turn terror into something with a shape and a reason. Out of that need, myth is born. Picture a winter night in the centuries after the impacts and megafloods. The climate has settled into its new, harsher rhythm. The stories have not. A band huddles around a fire in a narrow valley, spared the worst of the continent-wide scouring. Children, wrapped in furs, stare at elders whose faces are carved with age and old grief. Outside the circle of light, the sky is cold and deceptively calm. Tell us again, a child insists, about the time the stars fell. The old woman nods. She has told this story 100 times, but each telling is also a remembering. She speaks of a night when the familiar constellations were shredded by streaks of fire, when the sky did not simply hold the stars, but hurled them down like arrows. She describes a sound like mountains breaking, winds that tore trees from the ground, rivers that rose up their own banks and ran backward. Her language is not technical, it is visceral. She does not speak of comet fragments, but of the sky hunters, spirits who loosed their burning spears. In another camp, years and miles away, a different elder speaks of water. His people lived by a great lake that was not content with its shores. In his story, the lake is an animal, sleeping, then suddenly awake, surging over its banks to chase the people up the mountain. He remembers clinging to a boulder as trees, animals, and houses were swept past in a churning, debris-choked torrent. Only those who reached a certain high ridge survived. In the retelling, that ridge becomes sacred, the place where the Earth Mother lifted her children above the drowning. Across generations, details shift. Human memory is vivid, but not precise. The old woman's streaks of fire become, in her grandchildren's mouths, literal stars knocked from the sky by quarreling gods. The lake animal's surge becomes a deliberate act of punishment for broken taboos. Moral lessons accrete around raw events. Do not be greedy. Do not make too much noise. Do not neglect your duties. Catastrophe, senseless in the moment, is retrofitted with cause and effect. What is remarkable is that when you step back and compare these stories, not just within one region, but across the globe, certain motifs recur with uncanny regularity. Fire from heaven. In Mesopotamia, texts speak of gods who rain down burning stones. In ancient Greece, Phaethon loses control of the sun chariot and scorches the earth before being struck down. In North American traditions, the sky is sometimes said to have fallen or opened, letting loose devastation. In Mesoamerica, some myths describe previous worlds ending in rain of fire before the current age began. Strip away the divine names, and you are left with a shared core. Something came from above, brilliant and lethal. Days of darkness. Biblical accounts of the flood mention windows of the heavens opening and fountains of the deep bursting. But elsewhere, we find descriptions of a world plunged into shadow. Mesoamerican codices speak of suns that die, plunging creation into cold. Norse myth remembers Fimbulwinter, a great winter before the end of the world. When snow falls from all directions, summers fail, and the sun seems dim. These could be exaggerations of bad weather, or folk memories of soot-darkened skies after continent-wide fires and dust-laden air after impacts. Mountains underwater. In the Greek story of Deucalion, the flood is so great that only the peaks of Parnassus remain above the sea. Many Pacific Islander myths recount ancestral homelands swallowed by rising waters, with only the tallest ridges surviving. Even inland cultures often speak of waters that reached the top of the world, likely hyperbole, but suggestive of floods that overtopped any local landmark their storytellers knew. Factor in post-glacial sea level rise, which really did drown coastal plains worldwide, and the image of a world where familiar high places suddenly became islands starts to feel less like fantasy and more like distorted reportage. Animals saved on boats or floating refuges. The story of Noah is the most famous. A righteous man warned of a coming flood, instructed to build an ark and save pairs of animals. But similar motifs appear from Mesopotamia's Utnapishtim to India's Manu, led by a divine fish to build a boat and survive a deluge. Indigenous traditions in the Americas describe people and animals fleeing to rafts, tree trunks, or floating mountains. In some Andean myths, a llama warns its master of rising waters, leading him to safety. The specifics differ. The skeleton is the same. Foreknowledge, preparation, rescue of more than human life. Did all these peoples independently invent the same dramatic images? It's possible. Floods and storms are universal experiences, and the human imagination gravitates towards certain archetypes. But when the motifs cluster around an epoch we know from physical evidence was marked by real planet-scale upheaval, another possibility emerges, that these scattered cultures were all, in their own ways, trying to encode lessons from a shared, traumatic, deep past. Viewed this way, myth becomes more than entertainment or morality play. It is a kind of cultural hard drive, a way to compress the message. The sky can burn, the sea can rise, everything you know can vanish into narratives engaging enough to be retold for thousands of years. Children who grow up with such stories are, at some deep level, inoculated against complacency. They may not understand orbital resonances, but they inherit a wary respect for rivers, coasts, and the capriciousness of the heavens. Of course, as time stretches and societies grow more complex, the practical warnings become entangled with theology, politics, and poetic elaboration. Divine councils argue about whether to destroy noisy humans. Heroes build perfect cubical arcs. World trees and cosmic serpents get involved. Yet inside these Baroque structures, a simple, grim kernel remains. Once, the world nearly ended. It could, in principle, happen again. We, who pride ourselves on having moved beyond myth, now reconstruct those same events with satellite data and isotopes. But the function is strangely similar. We build models and graphs not just to understand, but to warn, to say to our descendants in our own technical tongue, this can happen. The difference is that our stories are written in equations, their drama flattened into lines on screens. The ancients wrapped theirs in gods and monsters to make them unforgettable. And somewhere between their metaphors and our measurements, the same image persists. Fire in the sky, flood on the earth, and a fragile species trying to remember across the long dark what it learned the last time the universe reminded us how small we really are. Out of all the flood tales, one figure appears again and again wearing different names and faces. The one who saw it coming. While most myths speak of whole people swept away, they almost always stop to focus on a single person or family that survives the deluge and wakes up in a stripped, silent world. That survivor is more than just lucky. He, or occasionally she, is a bridge, a hinge between eras, carrying knowledge across a rupture so deep that everything before and after might as well be different planets. In ancient Mesopotamia, that figure is Utnapishtim. In the Epic of Gilgamesh, we meet him not as a hero in mid-struggle, but as a finished legend, living in a distant paradise at the mouth of the rivers. When Gilgamesh, shattered by his friend Enkidu's death, seeks the secret of immortality, he is told to find Utnapishtim, the faraway, the man who survived the great flood and was granted eternal life by the gods. When they finally meet, Utnapishtim is underwhelming. No shining god, just an old man. But the story he tells is anything but ordinary. Long ago, he says, the gods resolved to wipe out humanity with a flood because human noise disturbed their rest. One god, Ea, or Enki, disagreed, but could not openly defy the council. So he whispered through the wall of Utnapishtim's reed hut, effectively speaking to the man without breaking his oath. Reed hut, wall, wall, listen, he began, then instructed Utnapishtim to tear down his house and build a vast boat. The dimensions are precise. The command is clear. Abandon possessions, save life. Utnapishtim loads his family, craftsmen, and the seed of all living things aboard. The flood that follows is described in language more visceral than symbolic. Storm gods unleash winds so fierce that even the gods themselves cower like dogs in the highest heaven, watching the destruction below. For 6 days and nights, the world is drowned. When Utnapishtim finally opens a hatch, humanity has turned to clay. His boat rests on a mountain. He sends out birds, first a dove, then a swallow, finally a raven that does not return. He steps onto a changed earth, offers a sacrifice, and the hungry gods swarm the smoke. In the aftermath, the chief god Enlil is furious that anyone survived, but Ea argues for mercy. As a compromise, Utnapishtim and his wife are granted a unique gift. They will live forever, but apart from humanity. Centuries later, in the Hebrew Bible, Noah stands in a similar position. In Genesis, the reason for the flood is not noise, but corruption and violence. Humanity has filled the earth with blood. Even the thoughts of their hearts are evil. The God of Israel resolves to blot out all living things, but Noah found favor in the eyes of the Lord. He is described as righteous, blameless in his generation. Like Utnapishtim, he receives detailed instructions. Build an ark of gopher wood, sealed with pitch, with exact dimensions. Bring aboard your family in pairs of all animals. Though a different version in the same text mentions 7s of the clean animals, hinting at older layers of tradition. The flood in Genesis lasts 40 days and nights in the rain, but the waters rule for much longer, covering all the high mountains under the whole heaven. When Noah seeks to know if the earth is habitable again, he too sends out birds. A raven that went to and fro, and then a dove that eventually returns with an olive leaf. When he leaves the ark, he builds an altar, offers sacrifices, and God establishes a covenant. Never again will all life be destroyed by a flood. The sign of this promise is a rainbow. In India, in the Shatapatha Brahmana and later texts, it is Manu who becomes the world's remnant. One day, as Manu washes his hands in a river, a tiny fish pleads for protection. He shelters it in a jar, then a tank, then a lake, and finally the ocean, as it grows to extraordinary size. The fish, an avatar of the god Vishnu, warns Manu that a great flood is coming, and instructs him to build a boat. When the waters rise and cover the land, Manu's vessel is towed to safety by the fish, tied to its horn. Alone on the receding ocean, Manu performs a sacrifice from which a woman is born. Through their union, the world is repopulated. Here, the survivor is not just a preserver, but a recreator, almost a second Adam. Elsewhere, variations proliferate. In Greece, Deucalion and his wife Pyrrha survive a flood sent by Zeus by building a chest and landing on Mount Parnassus. In some versions, they repopulate the earth by throwing stones over their shoulders that turn into people. Among the Maya, in one cycle, an earlier world is destroyed by flood and jaguars, with a few survivors clinging to trees or mountaintops. In Andean myths, A shepherd warned by his llamas flees to a high peak while waters engulf villages below. In China, stories of Yu the Great battling a cosmic flood blend engineering feats with half-remembered disaster. The pattern is clear. Warning, often from a god or a talking animal. Construction of an extraordinary vessel or refuge. Collection of life, whether animals themselves or their seed. Deluge that overwhelms ordinary geography. Landing on a high point. Sacrifice or ritual. A covenant, instruction, or new order for the world after. Are these simply narrative conveniences, moral allegories about obedience and righteousness? Certainly they are that. Each culture shapes the flood survivor to reflect its ideals. Pious Noah, clever Utnapishtim aided by a trickster god, dutiful Manu, who protects even a humble fish that turns out to be the divine. Their stories teach listeners how to behave if they want to be among those saved, whether by gods or by their own foresight. But it is also possible, perhaps even likely, that behind these polished mythic figures stand real people or families who noticed dangers sooner, who read the river or the sky differently, who moved camp to higher ground or built sturdier boats when others hesitated. In a time when knowledge was not written, but embodied in elders, a leader who successfully guided their people through a once-in-a-thousand-generations catastrophe would have become more than a chief. They would have become a living archive. Imagine the weight of that. You have seen things no one else alive remembers. A shoreline 10 days' walk seaward of the present one. Herds of animals your grandchildren know only from bones. A sky on a particular night that burned like a second sun. To those who grow up in the aftermath, your stories are the only bridge to a lost world. They gather around you, not just for entertainment, but for orientation. What happened? Could it happen again? What did you do? As you age, the realization creeps in that when you go, so does that direct memory. Panic drives you to repeat the stories, to compress your experience into phrases and images vivid enough to survive retelling. You become Utnapishtim, he who saw the deep, or Noah, rest, or Manu, man. Your individual biography is swallowed by the archetype. You're no longer just yourself. You are the one who survived. The loneliness at the heart of that role is easy to miss under the mythic glow. We see the ark on calm waters, the rainbow, the mountain peak emerging from the flood. What we rarely dwell on is the moment when the water has gone and the silence settles. When you step onto mud that once held forests and cities, and realize that every friend who did not listen, every face you remember from the time before, is gone. The new world smells of damp silt and beginnings, but you carry an ending inside you that no one else has seen. In that sense, the flood survivor is not just a hero, but a trauma bearer. Someone who holds a memory almost too big for one mind. Myth, by turning them into a story everyone can tell, shares that burden out. It lets the experience of nearly losing everything become not just one person's private nightmare, but a culture's cautionary tale. For the first generations after the cataclysm, the stories were like open wounds, raw reports of fire, water, and loss. But as centuries passed and the world's new normal settled in, another layer wrapped itself around those memories, a moral skin, a way of saying not just, "this happened," but "this happened for a reason." In that transformation, the death of mammoths and the freezing of fields became something more than tragedy. They became judgment. Imagine a child born a few hundred years after the last mammoth in their region has fallen. They grow up on a tundra where only reindeer, smaller deer, and tough, scrubby shrubs persist. Around the hearth, elders speak of an earlier time when The great hairy ones walked, when hunters could bring down a single beast and feed the whole camp for days. The child hears how the sky burned and floods rose. They also hear quieter confessions slipped into the tales. We hunted too many. We sang too loud. We forgot proper offerings. In a purely material sense, our ancestors watched an ecological web unravel. When the big grazers disappeared, grasslands changed. Fires behaved differently. Predators vanished or shrank. Plant communities shifted with the altered climate. Rivers froze earlier, thawed later. Seasons seemed to betray their old patterns. A spring that never arrived on time, a migration that never came. These were not abstract climate anomalies. They were broken promises from a world that had once been hostile but reliable. In trying to understand why the contract had changed, people did what we still do under stress. They looked for fault. The Mesopotamian flood myth, as Utnapishtim tells it, frames the god's motive in almost comically petty terms. Humans are too noisy. Their clamor keeps the great god Enlil from sleeping. Annoyed, he decides to exterminate them with a flood. Underneath the anthropomorphic irritation, however, is an observable fact. Human numbers and activities had grown. Camps became villages. Villages became towns. Fires, hunts, and fields multiplied. From the point of view of someone attuned to the subtle rhythms of nature, the expansion of human presence could indeed feel like an escalating din. More smoke in the air, more trees felled, more animals driven. In Genesis, the charge is more severe. The earth is filled with violence. Corruption and bloodshed are named as reasons for the flood. To a later theologian, these are spiritual failings. To someone living through ecological strain, they could be literal. When prey is scarce, hunters grow ruthless, encroaching on each other's territories. Raids for food and land intensify. Overkill, conflict, and environmental stress braid together. The sense that something has gone wrong in the relationship between humans and the rest of creation becomes inextricable from the sense that something is wrong in the relationship between humans and the divine. In other cultures, the flood or great cold comes because people have broken taboos. In some Pacific myths, overfishing or disrespect for sea creatures angers an ocean deity who responds with a storm. In certain Native American traditions, the animals convene and decide that humans have become too greedy. A great change, flood, fire, or ice, is their vote of no confidence. The cosmos is not indifferent. It listens, weighs, and reacts. It would be easy to dismiss this as superstition, but there is a subtle ecological intelligence at work. Ancient storytellers may not have known the physics of impacts or the mechanics of thermohaline circulation, but they could see feedbacks. When we do X too much, Y gets worse. When we take without balance, the land punishes us. Guilt and pattern recognition intertwine. The god's wrath becomes a way of talking about ecosystem backlash, externalized into personalities so that lessons can be taught, remembered, and emotionally felt. The disappearance of mammoths is a focal point in this moralization. For thousands of years, these animals had been central not only to diets, but to identities. Their ivory carved, their bones used for dwellings, their images scratched into cave walls. To see them vanish in the span of a few lifetimes must have felt like being abandoned by patrons or guardians. You can imagine an elder, watching a snow-covered plain where no silhouettes move, saying, "We took too much. The great ones left because of us." Couple that with celestial terror, the remembered night when fire fell, and a powerful narrative fusion forms. We offended the powers, and they took back what they had loaned us. The mammoths, the mild summers, the predictable rivers were all provisional gifts. In violating some cosmic etiquette, humans triggered not only a physical catastrophe, but a legal one. The court of gods convened, heard the charges, and issued a sentence. Flood, frost, famine. In this light, the gods of later pantheons are not abstractions pulled from thin air. Stormbringers like Enlil, Zeus, or Tlaloc are personifications of forces that, in living memory, had gone berserk. Sea lords like Poseidon or Njord rule not just over calm trade and fish, but over surges that swallow coasts. Sky arrows, thunderbolts, flaming darts echo meteor fire streaking down. Each deity's wrath is a mythic recasting of real, terrifying behaviors observed in wind, water, and stone. Did ancient people consciously link their own expansion to these events? Some must have. A hunter who watched the last of a local herd slaughtered was fully capable of thinking, "We did this." A villager who saw forests cleared upriver and then endured new floods could suspect cause and effect. But in cultures without written records or formal science, those intuitions were easiest to transmit when wrapped in stories of gods and punishments. Where cosmic backlash stood in for the more mundane but equally inexorable responses of a stressed environment. So the day the mammoths died becomes in story, not just the day a species went extinct, but the day a verdict was rendered. Humans in these narratives are on trial not only for how they treat one another, but for how they treat the world. The sentence, flood, fire, endless winter, is terrifying. Yet embedded in it is also a warning and a chance. Change your ways. Remember the cost. And perhaps the judges will relent. We, reading these myths with ice cores and extinction graphs in hand, can see something the storytellers could not. That sometimes the hammer falls from a blind universe, not a moral one. But we can also see that our ancestors' instinct to tie environmental collapse to human behavior was not wholly misguided. In our age, the gods have new names: carbon, feedback, tipping point. But the feeling is familiar. The sense that when we push the world too far, something larger will answer. In the myths, the sky's anger is a singular event, a once-and-for-all verdict. But in the language of orbits and gravity, anger can be periodic. The forces that flung fire at Earth 12 to 800 years ago did not simply vanish afterward. They settled into new paths around the sun, invisible lines of stone and ice crossing our own. To understand just how precarious our situation still is, we have to follow one of those lines. The path of a ghost. The Taurid meteor stream. Picture the solar system from above. The sun a blazing coin at the center. Planets tracing nearly circular tracks around it. Between and beyond those planets move lesser bodies. Asteroids, comets, fragments, dust. One of these structures is the Taurid stream, a broad, diffuse river of debris looping around the sun on an elongated orbit. Its particles range from dust grains to boulders hundreds of meters across, all moving together like a slow-motion cloud. Most astronomers now believe the Taurids are the remains of a once enormous comet, perhaps 50 to 100 kilometers across, that entered the inner solar system tens of thousands of years ago. Repeated passages near the sun and gravitational tugs from planets slowly tore it apart. Each time it disintegrated a little more, it shed material along its orbit, thickening the stream. Over millennia, that rubble spread out, but it still clings loosely to the path of its long-dead parent. Twice a year, Earth crosses this debris river. In late June and early July, and again in late October and early November, our planet's orbit intersects the Taurid stream. Most of the time, we notice this only as a modest meteor shower. The June Taurids, the more famous southern and northern Taurids of autumn. Go outside on a clear night during these periods, lie back, and you'll see a few slow, bright streaks scratching the sky, often with a lingering glow, the dusty remnants of the ancient comet vaporizing high above you. Harmless, beautiful. But that is the gentle face of the Taurids. In recent decades, astronomers analyzing fireball records and orbital data have noticed something unsettling. The stream is not uniform. Embedded within it appear to be denser pockets, swarms, where larger objects cluster. When Earth's orbit threads one of these swarms, the number of bright fireballs increases dramatically. Records from the 20th century show such enhancements in certain years, suggesting that clumps of bigger debris occasionally cross our path. Some of these larger Taurid fragments have already been catalogued as near-Earth objects. They include asteroids hundreds of meters wide on orbits that match the Taurid stream. These bodies are not dust. If one of them were to strike Earth or explode low in the atmosphere, the result would not be a pretty shower, but a catastrophe. A city erased, a region scoured. Now extend that logic backward in time. If a fragment only 50 to 100 meters across could produce something like the 1908 Tunguska blast, what could a swarm of multi-hundred-meter objects do if intersected during a denser era of the stream's evolution, say, shortly after the parent comet's major breakup? The Younger Dryas impact hypothesis suggests that 12,800 years ago, Earth did exactly that, plowed through a richer, more dangerous section of the Taurids, encountering multiple large fragments in quick succession. The result? Widespread airbursts, fires, floods, a jolted climate. Orbital simulations lend weight to this idea. When researchers model the evolution of a large comet's debris over tens of thousands of years, they find that its fragments can cluster in resonant patterns with Jupiter's gravity, forming swarms that periodically intersect Earth's orbit. Some estimates suggest that the Taurid stream may still harbor dozens, perhaps hundreds, of kilometer-scale objects, civilization enders lurking amid harmless pebbles. From the ground, there is no obvious sign. The Taurids do not announce their more dangerous members with special colors or trajectories. A swarm-year meteor shower might simply seem a bit more spectacular. More fireballs, more wows from people on dark hillsides. Yet for the planet, the difference between nice light show and new geological epoch could be just one unlucky alignment of paths. Visualize it. The silent geometry of space. Earth rushing along its orbit at 30 kilometers per second. The Taurid debris like a tilted, elongated hoop crossing our track. Most years we pass through a thin section, dust hissing against our atmospheric shield. Our species makes wishes on the falling stars. But threaded along that hoop are thicker knots, denser sections that we only occasionally hit. The Younger Dryas may have been one of those appointments, a bad crossing. The disquieting part is that the schedule did not end there. The Taurid stream is still out there, coiling around the sun. We still carve through it twice a year, as reliably as we flip calendar pages. Our improved telescopes and sky surveys now track many of the larger objects, but not all. Nightly, automated systems scan for moving points of light, fit orbits, update risk lists. Most days, the news is quietly reassuring. No imminent threats. Yet the knowledge that we are wading through the spilled guts of a giant, shattered comet never quite goes away. In ancient times, people saw only the visible part. A comet blazing a tail, a sudden spike in meteors, then, sometimes, bad years. They strung those coincidences into stories of omens, dragons, spears of light. We, with our charts and models, see the pattern more clearly, but the emotional truth is similar. The heavens are not a static dome. They are a moving machine, with gears we barely understand. Some of which, on certain cycles, mesh in ways catastrophic for anything unfortunate enough to be in the wrong place at the wrong moment. The Younger Dryas, from this perspective, stops being a freak accident and becomes one tick on a repeating celestial clock. We do not know when the next large swarm intersection might occur. It could be tens of thousands of years from now. It could be sooner. What we do know is that the path is still there, the debris still flows, and our planet continues, obediently, to keep its appointments along that invisible, deadly river of stone. If the Taurid stream is a kind of invisible script written in the sky, then the megaliths of the early Holocene may be humanity's attempt to write a reply in stone. Long after the last mammoth fell and the Younger Dryas cold eased, people in scattered corners of the world began dragging multi-ton blocks into deliberate patterns, building monuments that outlasted their makers by thousands of years. The usual explanations, ritual, burial, community gathering, are almost certainly true. But under those lies another possibility, that some stones were raised not just to honor the dead or the gods, but to watch the heavens for the return of fire. High, on a hill in southeastern Turkey, buried for millennia beneath backfilled earth, sits Gobekli Tepe. When archaeologists uncovered it in the 1990s, it upended assumptions. The site dates to around 11,600 years ago, almost exactly when the Younger Dryas ends. Its builders were, as far as we can tell, still hunter-gatherers. No cities, no ceramics, no metal. Yet they carved towering T-shaped pillars from limestone, some up to 6 meters tall and weighing many tons, then arranged them in circular enclosures. On the pillars they carved foxes, snakes, vultures, boars, and abstract symbols. To the mainstream view, Gobekli Tepe is the world's oldest known temple, a place where early societies gathered for feasting, ritual, perhaps to negotiate emerging hierarchies. Its art reflects a symbolic world where animals were charged with mythic meaning. But some researchers have suggested a further layer, that the animals correspond to constellations, and that certain arrangements might encode a memory of a great meteor shower or impact associated with the Younger Dryas. One controversial study proposed that a particular pillar, with a vulture, scorpion, and other figures, maps onto the sky as it would have looked around 10,950 BCE, close to one proposed date for a major impact. In this reading, Gobekli Tepe becomes not only a ceremonial center, but a kind of three-dimensional star chart, freezing in stone a pattern that human eyes once saw writ in fire. Even if the exact correlations are debated, the idea that these people cared deeply about the sky is hard to dismiss. The site's elevated position, its open, circular architecture, all seem designed for gatherings under the stars. A few thousand years later, and far to the northwest, on the windswept plains of southern Britain, a different ring of stones rose, Stonehenge. Its origins lie around 3000 BCE, when an earthen bank and ditch were constructed. The iconic sarsen stones and smaller blue stones were erected roughly 5 centuries later. Here, the astronomical alignments are clear and widely accepted. The main axis of the monument lines up with the midsummer sunrise and midwinter sunset. On the solstices, the sun rises or sets exactly over particular stones, transforming the circle into a theater of light and shadow. Stonehenge's builders, descendants of people who had lived through lesser but still significant climate swings and sea level changes, seem to have been obsessed with tracking the solar year. Knowing precisely when seasons turned could make the difference between a successful harvest and famine. But there is also something of cosmic reassurance in fixing the sun's behavior in stone. After an age when the sky once betrayed humanity, marking its most predictable rhythms may have felt like a ward against further surprise. Beyond the famous sites lie countless others. Stone rows in Brittany, circles in Scotland and Ireland, standing stones in the Caucasus, enigmatic alignments in the Arabian Peninsula. Many of these structures are oriented toward solar risings and settings, lunar standstills, or particular bright stars. In some cases, alignments seem to mark the heliacal rising, the first dawn appearance of specific constellations that, in ancient lore, were associated with catastrophe. Scorpius, the Pleiades, or regions of the sky through which major meteor streams appear to radiate. Did ancient astronomer priests deliberately tune their monuments to regions of the sky tied, in inherited memory, to past horrors? Or are we reading too much into patterns that, to their builders, were simply spiritually resonant? Modern archaeoastronomy walks a tightrope here. On one side is justified caution against projecting our narratives onto stones. On the other is the increasingly undeniable fact that many early societies invested enormous labor in constructions that connect earth and sky in precise ways. What if we think of these megaliths not as exotic, mystical outcrops, but as instruments of continuity? Imagine a culture rocked, not by a single disaster, but by the knowledge that disaster can come from above without warning. Oral tradition preserves the broad strokes for a few centuries, then begins to fray. People forget details. Which part of the sky the fire came from, which season, which omens preceded it. A few visionary individuals, call them shamans, priests, sky watchers, realize that memory alone is fragile. So they do something our species is only just learning to value again. They build long-term markers. A stone aligned to a particular rising star says, silently, "Look here, on this day." A ring that captures the exact winter solstice sunrise says, "The year turns now, no matter what else changes." A complex of pillars perhaps encoding the sky at a pivotal moment says, "This pattern mattered. Remember it." For people used to measuring time in lifetimes, these are audacious acts. Messages to descendants thousands of years down the line. Most archaeologists rightly emphasize that these monuments were multifunctional, social hubs, burial sites, theaters for ritual. But beneath the feasting and chanting, beneath the processions and burials, there is always that upward axis. Stones reaching not just into the earth as anchors, but into the sky as pointers. What were they so desperate not to forget? The safe story is that they wanted to remember when to plant and when to harvest. The less comfortable possibility is that, somewhere in their collective past, the sky itself had once changed the rules without warning, and they were determined to keep watch, in stone, against the day it might try again. On a low, rounded hill in southeastern Turkey, the earth once looked ordinary. Fields of barley, patches of scrub, the occasional flint flake turned up by a plow. Locals called it Potbelly Hill, Göbekli Tepe. Nothing about its surface betrayed that beneath lay one of the strangest and most important archaeological discoveries of the last century. A temple complex older than pottery, older than cities, older than the wheel. Older, in fact, than any other megalithic monument we know. Born almost exactly as the Younger Dryas, cold snapped off, and the world warmed again, around 11,600 years ago. When excavations began in the 1990s under the direction of Klaus Schmidt, the first glimpses were baffling. Workmen exposed massive limestone blocks, T-shaped pillars, set upright in circular enclosures. Some were as tall as 2 or 3 people, weighing up to 20 tons. They had been quarried from the hill itself, dragged and erected with a precision that speaks of planning and coordination. The pillars were not crude. Their edges were sharply dressed. Some had relief carvings so fine that individual hairs on an animal's pelt could be seen. Walking among them now, after years of excavation, feels like stepping into a frozen congregation. Each circular or oval enclosure has a ring of T-pillars around its edge and two larger Ts standing in the center, facing one another like silent twins. The T-shapes are not random. Many scholars think they represent stylized human figures, bodies without heads, arms carved along the sides, hands meeting at the waist. Belts and loincloths are etched in shallow relief. If so, each pillar is a kind of stone ancestor, a giant standing witness. Around and on these bodies, animals swarm. Foxes, wild boar, aurochs, gazelle, snakes, scorpions, vultures, cranes, creatures familiar to a late Ice Age hunter, and yet here they are, flattened into symbols, organized in deliberate compositions. A vulture holds a human head. A headless man, erect phallus exposed, tumbles beside dangerous beasts. Snakes writhe in bands. On one famous pillar, a menacing array of creatures gathers around abstract signs. Circles, half-moons, H-like glyphs. Mainstream interpretation sees Gobekli Tepe as a ritual center for mobile hunter-gatherers who converged here periodically to feast, trade, and perform ceremonies. No houses or obvious domestic debris have been found nearby. No hearths full of daily cooking scraps, no trash middens. Instead, there are massive stone basins, butchered animal bones in great numbers, and layers of intentionally placed fill. It looks less like a village and more like a pilgrimage site. The chronology is startling. Radiocarbon dates place the earliest, most monumental enclosures at around 9600 BCE, with later, smaller circles built atop earlier ones over the next few hundred years. Then, for reasons we do not yet fully understand, the builders did something extraordinary. They buried their own work. Enclosures were deliberately filled in with rubble and soil, the pillars entombed. The hill grew as these infills accumulated, sealing the structures away as if they were fossils being carefully packed for preservation by the very people who raised them. Why? One line of thought suggests religious change, a new set of beliefs supplanting the old, with the previous temples respectfully retired. Another, more haunting possibility is that the builders were themselves the children or grandchildren of a catastrophe, aware that worlds can end, and they were trying to send a message forward. Bury the stones, protect them from erosion and war and accident, so that some distant future might dig them up and remember. Into this charged context enters a provocative idea that some of Göbekli Tepe's carvings are not just symbolic animals, but constellations, that the site encodes the sky of a specific time, and perhaps even a record of an impact. The pillar often cited in this regard, known as the vulture stone, shows a vulture, scorpion, bird, and other figures arrayed around an abstract symbol some have likened to a headless human. One controversial study argues that these match constellations as they would have appeared around 10,950 BCE, close to one proposed date for the Younger Dryas onset, suggesting that the pillar is a carved memory of a time when the world burned. Most archaeologists remain skeptical. The risk of seeing star maps where none were intended is real. Our brains are pattern machines. Yet, even setting aside specific identifications, certain facts remain. Göbekli Tepe sits on a high ridge with sweeping views of the horizon. Its enclosures are open to the sky. Their axes could have easily been aligned to celestial events. The people who built it invested staggering effort, cutting, transporting, and erecting tens of thousands of tons of stone, without the economic base of agriculture. They did this at precisely the moment when the climate stabilized after centuries of chaos. It is not hard to imagine that these hunter-gatherers carried, in their elders' stories, living memories of a colder, darker time, of failing herds, bitter winters, strange lights in the sky, or floods in the lowlands below. Some may have been descendants of groups that once lived in late glacial refuges along now-drowned coasts, bringing with them mythic fragments of an older, more complex culture. To them, the world beyond their hill would have felt newly reopened, but also fragile. Raising a forest of stone ancestors and animal spirits under the vault of heaven could have been both thanksgiving and insurance policy. In the pillars of Gobekli Tepe, we glimpse something that does not fit our tidy ladder of progress. Civilization here does not slowly climb from simple huts to grand temples. The grand temple comes first, as if built from a template remembered rather than invented, and only later do we see settled villages and fields of domesticated wheat spreading through the surrounding region. It is as if, in the wake of the Younger Dryas, after fire, flood, and long winter, a remnant of an older script was pulled from humanity's deep memory and reperformed in stone on an Anatolian hill, whether or not its carvings literally record a falling comet. Gobekli Tepe is undeniably a monument to transition. Between ice and warmth, between roaming and settling, between a world where the sky nearly killed us and one where we began, cautiously, to trust it again. If Gobekli Tepe is a stone memory on land, then the oceans may hide the rest of the story. Because if there really were societies more complex than we expect before the great floods, their greatest cities would not be on the mountaintops where we now dig. They would be along the coasts, on shorelines that during the last ice age lay far seaward of today's. And those shorelines are gone, not in myth, but beneath up to 100 meters of water. At the peak of the last glaciation, so much water was locked in ice caps that global sea level stood roughly 120 meters lower than now. The familiar map of Earth would have looked very different. Continental shelves, those shallow fringes that today lie just offshore, were exposed as broad coastal plains. Rivers extended much farther out, winding across these flats before reaching deeper water. Estuaries and deltas, where fresh and salt met, were likely rich in fish and shellfish. If you were a late Ice Age human looking for a place to camp or settle, those zones would have been prime real estate. We can still trace their outlines, not by walking them, but by scanning them. Sonar pulses sent from research vessels bounce off the seafloor and return patterns that can be turned into maps. In many places, those maps show ghost landscapes, drowned river valleys, terraces, even what look like ancient shorelines stepping down into the depths. On continental shelves off India, the Mediterranean, Northern Europe, and the Americas, we see unmistakable signs that once, not long ago in geological terms, dry land stretched where waves now roll. Off the modern coast of India, in the Gulf of Comet and near the city of Dwarka, controversial discoveries have stirred debate. Sonar surveys there have revealed geometric patterns on the seabed, rectilinear features, mounds, anomalous lines, at depths that would have been dry ground more than 8,000 to 10,000 years ago. Divers have retrieved worked stone and artifacts from nearby areas. To some, these are the fragmentary remains of ancient port cities, perhaps the inspiration behind later tales of Dwarka, the drowned city of the god Krishna. Most archaeologists urge caution. The ocean is cunning at creating shapes that look artificial. Ripples, rock outcrops, erosion patterns. Artifacts can be transported by currents from more recent wrecks or eroding shorelines. Radiocarbon dates from organic material on such sites often span wide ranges, making precise timelines slippery. Yet, even the skeptics agree on one thing. If early maritime-focused societies existed, this is exactly where their traces would be hardest to find. Under tens of meters of opaque, sediment-laden water. In the Mediterranean, the pattern repeats on a different scale. Submerged structures off the coasts of Israel, Lebanon, and Greece show stone walls, pavements, even entire Neolithic villages preserved under sand and silt. At Atlat Yam, off Israel, an 8,000-year-old village lies 9 meters below the surface, its stone houses, wells, and a circle of megaliths remarkably intact. Here, no one argues the site is lost civilization in the mythic sense. It fits comfortably into the known Neolithic timeline. Yet it proves a crucial point. Human communities, some fairly sophisticated, did indeed hug coasts that are now drowned. North of Europe, the North Sea hides an even larger ghost. Doggerland, a vast plain that once connected Britain to the continent. Archaeologists fishing up peat and sediments from the seafloor have found bones of mammoths, lions, and human artifacts. Tools, hearth remnants. During much of the late Ice Age, Doggerland was a habitable, even rich landscape of rivers, lakes, and rolling hills. As sea levels rose at the end of the Younger Dryas and beyond, storm surges and gradual encroachment turned it into a patchwork of islands, then finally into the shallow sea modern fishermen traverse. In the Americas, sonar and underwater archaeology along now-drowned river mouths hint at similar stories. Off Florida's Gulf Coast, paleochannels, old riverbeds, extend far seaward, their mouths now in tens of meters of water. In some, researchers have found ancient springs, ledges, and caves that would have been attractive sites for early people. Off the Pacific Northwest, hypothesized coastal migration routes for the first Americans would have run along shorelines now completely submerged. The fact that our oldest interior sites show up almost as soon as the climate allows for easier access suggests people may already have been moving along those lost coasts for millennia. When we stitch these clues together, a picture emerges that is less romantic than Plato's Atlantis, but no less evocative. During the late Ice Age and its tumultuous end, some of the best places on Earth to live, mild, food-rich, easily navigable, were not the harsh interiors we've mostly excavated, but the coastal shelves now underwater. Here, bands of hunter-fishers could have grown denser, experimenting with semi-permanent camps, early cultivation, and maritime trade long before inland regions saw anything comparable. If any truly advanced pre-flood societies existed, not with skyscrapers and silicon, but with complex social structures, seafaring, and monumental architecture. This is where their capitals would likely have stood, not high on lonely mountaintops, but beside estuaries and harbors, their wharves and temples slowly swallowed as the ice sheets collapsed and the seas rose in pulses of meters per century. We have only just begun to look for them in earnest. Underwater archaeology is expensive, slow, and technically demanding. Most surveys focus on shipwrecks, relevant to known historical periods, not on seeking foundations 10,000 years older. Yet with every submerged village we map, every drowned forest we find, the old question, where is the evidence, begins to sound less like a dismissal and more like a challenge. We've barely searched where the evidence ought to be. Perhaps, in time, Aravs and divers will trace a regular line of dressed stone along a drowned riverbank, or uncover a harbor wall older than any inland temple. Or perhaps we will find only scattered camps, fire pits, and fish bones, and the notion of cities before cities will remain speculative. But either way, one truth is clear. If there was a literal Atlantis, it did not need crystals or aliens. It only needed ice, melting, and time. The oceans themselves are its keeper, and we are only now, tentatively, learning how to ask them what they remember. For all the drama etched into ice cores and sea floors, our everyday sense of time is small. We remember our own childhoods vaguely, our grandparents' stories a little better. And beyond that, the past turns into a blur of long ago. As a species, we're not so different. We remember birthdays and wars, events that fit comfortably into written records. But not ice ages, not nights when the sky turned to fire. Those we recall, if at all, as myths. Somewhere between the Younger Dryas and the first written clay tablets, something slipped. We forgot most of our own childhood. On short timescales, human memory can be astonishing. In traditional societies with strong oral cultures, storytellers can recite epics tens of thousands of lines long, word for word. Genealogies can be chanted back 20 generations. Place names encode ecological knowledge, where water lies in drought, which plants heal or poison. This memory is not stored in books. It is distributed across people, rituals, songs, and taboos. It is robust against the failure of any one individual, but fragile in the face of disruption. Think of oral tradition as a rope woven from many voices. Pull it taut for a few centuries, and it can bridge surprising distances in time. But cut it through plague, war, displacement, or the death of key elders, and it frays quickly. Within 3 or 4 generations, details blur. The sharp edges of, "This happened to my grandmother," soften into, "They say that long ago." Specific dates vanish. Locations merge. Multiple events collapse into one archetypal story. The Younger Dryas impact, if it happened as the evidence suggests, predates writing by roughly 7,000 years. For all that time, its memory, if preserved at all, had to travel entirely in that oral medium, through people who themselves were living through other crises, lesser floods, famines, migrations, conflicts. Each new upheaval laid its own traumatic sediment over the old, like layers of silt burying older riverbeds. At some point, the original cataclysm stopped being a lived memory and became a backdrop, an origin story everyone knew, but no one had seen. By the time the first cities rose in Mesopotamia and Egypt, human attention had shifted from surviving planetary swings to negotiating human ones. Droughts and local floods still terrified. But the immediate threats were now rival kings, invading armies, failing harvests. Writing, when it appeared around 3200 BCE, was invented not to record cosmic trauma, but to track grain, taxes, and laws. Scribes scratched the concerns of palace and temple onto clay, not the half-remembered nightmares of ancestors. The great deluge stories that did eventually make it into cuneiform, the flood of Utnapishtim, Atrahasis, are already mythologized, moralized, compacted into theological arguments. Between the Younger Dryas and those tablets, countless smaller disasters intervened. Regional floods, volcanic eruptions, epidemics, social collapses. Each demanded its own explanations, its own stories of gods displeased or demons unleashed. The original wound of the Ice Age's end became just one more layer beneath many others. Even when people invoked the flood as a reference point, the worst that could be imagined, that phrase no longer pointed cleanly to a single event. It had become a symbol of ultimate upheaval, floating free of its geological anchor. This is the heart of the amnesia hypothesis. The idea that we live in a world built atop older worlds, using patterns we did not fully invent, while no longer consciously remembering where those patterns came from. We assume that everything important began with the first names we can write down: Sumer, Egypt, the Indus, because that's where our documents start. But what if those civilizations themselves stood on the shoulders of cultures erased not by mere conquest, but by sea level rise and climate whiplash. There is an uncanny feeling that many people report when they encounter truly ancient sites or concepts. Standing at Gobekli Tepe, or staring at the ages implied by ice cores, civilization feels both shockingly recent and impossibly old. On the one hand, all of recorded history, every pharaoh, every empire, every philosopher, fits into a neat 5,000-year column. On the other hand, anatomically modern humans like us have been around for at least 200,000 years. That leaves vast stretches of time, our long, dim childhood, largely unaccounted for. We tend to fill that gap with assumptions that life was always small-scale, simple, primitive, until the sudden flowering of writing and cities. But the physical record hints otherwise. Sophisticated stonework, early astronomical awareness, submerged settlements. It's as if we woke up in a furnished house whose previous tenants moved out abruptly, leaving some of their tools, some of their blueprints, but took their journals with them. On a psychological level, forgetting may have been necessary to carry, in full detail, the memory of near extinction for thousands of years could paralyze a culture. Grief blunts over time for individuals. Perhaps it had to for societies as well. The raw terror of fire and flood dulls into awe of gods, then into ritual, then into holiday. The original warning, "The sky can do this," remains, but wrapped in so many layers of story and symbol that its practical urgency is lost. Sociologically, each new era rewrites the past to suit its present. Kings trace their legitimacy to gods, not to ragged survivors of an older age. Priests emphasize covenants and commandments, not the fluke of being on a particular hillside when the water stopped. Historians, once they appear, focus on archives and chronicles, not on tales told in the dark by people whose languages are no longer spoken. Yet traces persist, like half-remembered dreams. Flood myths in dozens of cultures. Obsessions with celestial omens. Monuments that seem, from their very inception, overbuilt for the societies that raised them. These suggest that beneath our conscious stories of linear progress lies another, more cyclical story we can almost, but not quite, recall. Rise, catastrophe, survival, forgetting, rise again. Walking through a modern city at night, lit by electric suns, it is easy to believe we are the first to have done anything so grand. But somewhere deep in our collective mind is a disquieting whisper that we are latecomers in a play whose first acts have been misplaced, acting from a script we found half-burned, improvising the rest, hoping that the audience, if there is one, never notices how much we've forgotten. Science, in its modern form, was born in rebellion against stories. For centuries, explanations of the world were wrapped in myth. Gods moved the planets, dragons drank the seas, floods came as punishment. The scientific method carved out a new territory, testable, repeatable, stripped of divine motive. Yet as we have drilled deeper into ice, mud, and rock, something unexpected has happened. Some of the old stories have begun to murmur back, their symbolism brushing against our data in ways too suggestive to ignore. Lay out a simple timeline on a table. On one side, geological and climatic markers. The onset of the Younger Dryas at about 12,800 years ago. Its abrupt end around 11,600 years ago. Pulses of sea level rise scattered across the next several millennia. On the other side, mythic chronologies, where they can be coaxed into dates. Plato's Atlantis destroyed 9,000 years before Solon, which, added to his own era, lands curiously close to the end of the Younger Dryas. Mesopotamian king lists that separate antediluvian rulers from post-flood dynasties with a world-altering deluge, Mesoamerican calendars that speak of previous suns, earlier worlds ended by water and fire before the current age began. The match is not exact. How could it be, with oral traditions and symbolic numbers? But the broad strokes align in an unsettling way. Geological records say, just as the Ice Age was easing, the climate snapped back to cold. Oceans surged, ecosystems reordered. Myths say, in the time before kings and cities, there was a great flood, fire from heaven, a long winter, after which a new order began. Coincidence? Perhaps. Or perhaps a shared ancestral trauma, filtered through different languages and theologies, landing in our lap as a scatter of stories that, when we finally acquire the tools to read the planet's own archives, echo what the rocks have been trying to tell us. Consider the flood of Utnapishtim in the Epic of Gilgamesh. It speaks of a deluge so total that all of mankind had returned to clay. The boat comes to rest on a mountain. Birds are sent out to test the waters. In Genesis, Noah's Ark likewise grounds on high ground as the waters receded from the earth. In Greek myth, Deucalion's chest lands on Mount Parnassus. In Andean tales, survivors cling to peaks while waters surge below. From a glaciologist's perspective, highlands genuinely would have been the safest places as lowlands flooded from melting ice and rising seas. In a world of real megafloods and drowning coastal plains, the mountaintop refuge is not pure fantasy. It is topographic common sense. At the same time, scientific detail can diverge sharply from mythic flourish. Nanodiamonds in a boundary layer have no obvious counterpart in any sacred text. Platinum anomalies, magnetic spherules. These are not the kinds of things a storyteller would notice, let alone encode. Conversely, the rainbow God sets in the sky as a covenant sign after Noah's flood has no specific geological analog. It is a psychological marker, a symbol of restraint and hope after terror. When we start trying to pair every image in Scripture with a physical phenomenon, we quickly overreach. Many scientists are wary of this entire exercise, and with reason. For centuries, natural philosophy was hobbled by allegorical thinking, bending observations to fit predetermined narratives. The fear is that, by letting myths talk back, we invite that fuzziness in again, undermining hard-won rigor. Ice cores do not care what Gilgamesh dreamed. Meteor streams do not align themselves to match poetic cycles. The power of science lies precisely in its indifference to our stories. Yet there is another camp, smaller but growing, who argue that shutting myth out entirely is also a kind of blindness. Myths, in this view, are not rival theories, but repositories of long-term human observation, compressed and distorted. A Navajo story about respecting the balance of game animals is not a population dynamics model, but it encodes, in emotive form, a sense of carrying capacity. A Babylonian text about gods darkening the sky with their anger is not a climate graph, but it reflects lived experience of dust-choked weather. Dismissing such tales as mere superstition risks discarding qualitative data about past events whose physical traces have eroded or lie beyond our sampling. The tension, then, is not just intellectual, it's emotional. We are uncomfortable letting fireside stories sit at the same table as mass spectrometers. It threatens the neat boundary we have drawn between the rational and the irrational, between people in lab coats and people in animal skins pointing at the sky. Accepting that a myth of a world flood might preserve a real memory of Younger Dryas sea level rise feels like ceding ground, as if the old ways of knowing scored a win. But maybe it is not a contest. Think of geology and mythology as two very different witnesses called to testify about the same crime scene separated by 12,000 years. The rock says, "I contain traces of soot, platinum, melt glass. Something hot and fast happened here." The story says, "The gods grew angry, the sky burned, the waters rose." Neither is complete. The rock cannot tell you how it felt to hide on a hill and watch a valley drown. The story cannot tell you the impactor's angle or composition. Put them side by side, and a fuller picture emerges. An event that was both physically violent and psychologically shattering. Of course, we must be careful. Just as ancient people could see omens in every comet, modern enthusiasts can see ancient astronauts or lost supertech in every impressive ruin. Not every alignment is meaningful. Not every myth hides a data point. The art is in disciplined listening, letting myths suggest hypotheses without dictating conclusions, letting data constrain interpretation without flattening the human experiences that gave rise to those stories in the first place. In the end, the question is not merely academic. We live in a world where our own actions are now capable of triggering global changes. Warming seas, shifting storms, rising waters. We are, in real time, generating the raw material for tomorrow's myths. Will our descendants, 10,000 years from now, read our climate graphs and satellite archives directly? Or will they inherit only fragments? Tales of a time when the seas chased cities and the skies turned strange, trying, as we are now, to see through the veil of story into the stubborn, indifferent truths of the earth beneath. If myths are one kind of courtroom testimony about the past, then the debate over the Younger Dryas impact hypothesis is the cross-examination. Here, in the fluorescent light of conference halls and peer-reviewed journals, the question is blunt. Did a cosmic impact help trigger the sudden return to Ice Age conditions? Or are we seeing patterns in noise? The answer matters, not just for reconstructing one remote epoch, but for how we handle extraordinary claims about our planet's history. On paper, the impact hypothesis is dramatic. Around 12,800 years ago, it says, Earth encountered fragments of a disintegrating comet, unleashing multiple air bursts and perhaps a few surface impacts. These set off continent-spanning wildfires, destabilized ice sheets, pulsed meltwater into the oceans, and kicked the climate into the Younger Dryas. The supporting evidence, as we've seen, includes nanodiamonds, magnetic spherules, melt glass, a global platinum anomaly, and that ominous black mat. When this idea was first formally proposed in 2007, it made headlines and raised hackles. Many geologists and archaeologists were skeptical for reasons both scientific and cultural. Scientifically, the case had glaring gaps. Where, critics asked, was the crater? The Chicxulub impact that helped end the age of dinosaurs left a 180-kilometer scar, now well mapped beneath the Yucatan. If the Younger Dryas event was truly global in impact, where was its smoking gun? Proponents replied that a fragmented comet exploding mostly in the atmosphere or over ice might not leave a single large crater. But to many, this seemed hand-wavy. After all, smaller craters, secondary features, or clear-shocked quartz, minerals deformed in characteristic ways by high-pressure impacts, should still be findable. Early reports of such markers were either absent or ambiguous. Then there was the black mat itself. Alternative explanations were ready at hand. Organic rich layers with charcoal can form in wetlands or from more ordinary fire regimes. Perhaps, critics argued, the black mat simply marked a period of environmental change and increased burning due to human activity or natural climate variation. No comet required. As for nanodiamonds and spherules, some studies questioned whether the reported particles were correctly identified or whether they could form in processes other than impacts, such as biomass burning or volcanic eruptions. Several high-profile papers took aim at the impact hypothesis. Teams revisiting key sites reported failing to replicate some of the original findings. One group argued that claimed nanodiamonds were misinterpreted. Another contested the uniqueness of the spherules. In the sometimes combative language of scientific controversy, the idea was labeled unsupported, implausible, even junk science in certain corners. For a while, it seemed the verdict was in. Case closed, no comment. But science is rarely that tidy. As years passed, new data arrived that complicated the picture. Independent research groups began finding platinum anomalies at or near the Younger Dryas boundary in multiple locations. Greenland ice cores, lake sediments in North America, even in South American deposits. Platinum is rare in Earth's crust, but common in some extraterrestrial objects. Its spike at this specific horizon, mirroring the more famous iridium spike at the dinosaur extinction boundary, nudged the needle back toward something from space happened here. Similarly, more detailed work on spherules and melt glass from a broad range of sites found that many did indeed bear the geochemical hallmarks of high-temperature formation, consistent with impact processes. The geographic spread was large, across a huge swath of the northern hemisphere, suggesting a widespread event rather than localized fires. Some soils immediately above the boundary showed evidence of abrupt ecological disruption, matching the timing of megafaunal extinctions and Clovis cultural decline in North America. At the same time, impact skeptics refined their positions rather than simply retreating. Some acknowledged that an extraterrestrial event might have occurred but questioned its climatic significance. Perhaps, they argued, a modest impact or airburst happened coincidentally during a period of already unstable climate, adding insult but not causing the core injury. Others suggested volcanic explanations for certain geochemical signals, or argued that human overhunting and gradual environmental stress remained sufficient to explain the extinctions without adding a comet to the mix. What emerges is less a dramatic victory for one side than a messy, iterative process. Claims are made, critiqued, revised. New proxies, platinum, microspherules, high-resolution dating, enter the fray. Some early overstatements are walked back. Some dismissals prove premature. Conferences feature tense sessions where slides of grainy particles and stratigraphic columns are dissected by colleagues who, despite sharp disagreements, share a common aim: to make the story fit the evidence as tightly as possible. For those of us watching from the outside, this can be confusing, even disheartening. We crave clear answers. Did a comet trigger the Younger Dryas or not? Was there a global flood or just a patchwork of local disasters? Yet the very churn of this debate is a sign that science is doing what it must. Extraordinary claims, like a civilization-jolting impact 12,800 years ago, demand extraordinary scrutiny. They should not be accepted lightly, nor, however, should they be rejected simply because they are disruptive, or because they rhyme too closely with myths we thought we had outgrown. Trust, in this context, does not mean choosing a charismatic advocate and believing them. It means understanding that our picture of the past is provisional, built from partial records and evolving methods. It means accepting that evidence can point strongly one way without reaching absolute certainty. And it means resisting two equal and opposite temptations: credulity, which grabs any exciting narrative that explains everything, and cynicism, which dismisses unsettling possibilities out of hand because they are unfamiliar or uncomfortable. Where does the Younger Dryas impact hypothesis stand today? Somewhere in the middle of that tension. No longer a fringe idea, not yet a universally accepted paradigm. A serious possibility buttressed by intriguing, sometimes compelling evidence, shadowed by unresolved questions and contested details. In other words, it lives in the same space it all are. Truly interesting scientific ideas occupy for a time. On trial, with the jury still listening, the witnesses still being called, and the final verdict not yet written into the textbooks. And perhaps that is fitting. A story about a sudden plunge back into winter at the dawn of our civilization should not be too easy to tell. The Younger Dryas begins like a slammed door and ends like a snapped finger. Around 11,600 years ago, the chemical tracers in Greenland's ice stop screaming deep freeze and jump, almost vertically, toward warmth. In some cores, the inferred temperature rise is on the order of 10 degrees Celsius in a few decades. On a climate graph, it's a knife edge. On the ground, it is the world rolling over in its sleep and waking up somewhere new. At first, the change arrives as a subtle easing. Winters bite a little less viciously. Snowpacks melt sooner. Rivers crack their ice earlier, sending cold, roaring water downstream, while lowland nights are still sharp with frost. Hunters who have grown used to lean years notice more shoots underfoot, more insects in the air, more birds at dawn. In valleys that have known only scrub and stunted trees for generations, saplings appear in clusters, then in crowds. Then the thaw gathers momentum. Glaciers, which had held their ground, or even advanced a little during the Younger Dryas, begin to lose the tug of war. Their lower tongues thin and retreat upslope. Crevasses widen into open chasms. Rock once locked under white armor emerges slick and bare. From above, the great ice sheets fringing the northern continents look ragged at the edges, their margins scalloped, their surfaces pocked with dark, melt-filled lakes that drain in sudden, spectacular outbursts. Sea level, which has been rising in fits and starts since the last glacial maximum, surges again. Over the next millennium or so, the oceans climb tens of meters, but not as a smooth curve. There are pulses, rapid jumps where shorelines can move inland hundreds of meters in a single human lifetime. Places that were safe from the highest known tides become, without warning, part of the intertidal. Sheltered coves become bays. Low plains transform into archipelagos, then into seafloors, leaving only chains of hills as islands. Seen from the perspective of someone living on one of those shrinking coasts, time compresses. Where your grandparents remember setting their camps by a river mouth miles farther seaward, you now launch your canoe from a different beach, marked by your own half-buried fire rings. Your children will, in turn, be forced to move again, abandoning familiar fishing grounds to the taste of salt. Yet in the long view of geology, these displacements are the flickering adjustments of a system snapping into a new stable state. As the ice retreats, continents breathe out forests. In Europe, birch and pine rush northwards and uphill, colonizing ground once locked in permafrost. Behind them come hazel, oak, and elm, weaving dense temperate woodlands where, in their parents' youth, only dwarf shrubs and lichens could cling. In North America, boreal forests chase the glaciers north, while deciduous trees take root further south. Lakes newly carved by meltwater fill, then spill, their outflows cutting fresh channels through moraines and bedrock, rearranging drainage networks in decades. The land itself feels different underfoot. Where there were endless open vistas across tundra, there are now walls of green. Paths must change. Hunting tactics must change. The megafauna that survived the Younger Dryas gauntlet share their ranges with newcomers, deer, wild cattle, pigs, suited to forest edge and glade rather than wind-scoured plain. For human groups, the shift from tracking herds across open country to navigating and exploiting patchwork mosaics of woodland, wetland, and field demands new skills, new tools, new stories. Critically, after a few centuries of volatility, the climate does something rare. It calms down. The wild swings of the Pleistocene, repeated glacial-interglacial lurches, give way to the relative stability of the Holocene. Temperatures still wobble, but within a narrower band. The great ice sheets, once the tyrants of the northern hemisphere, dwindle to the more modest caps of Greenland and Antarctica. Seasonal cycles become more predictable. In the jargon of climatology, Earth's system settles into a new attractor. In human terms, the sky and seasons become, at last, reliable enough to bet your life on. For people scattered across Eurasia, Africa, and the Americas, this is a second chance written in weather. Bands who had survived by constant movement, following reindeer or bison along ancient routes, now find certain spots consistently rich. River bends where fish always seem to run, valleys where wild grains ripen in abundance each year. Floodplains that, though occasionally dangerous, leave behind fresh, fertile silt. Instead of moving through such places as temporary stopovers, some groups linger longer each season. Structures get a little sturdier, storage pits a little deeper. The line between camp and village begins to blur. In the Fertile Crescent, where Gobekli Tepe's stones already stand on their hill, people experimenting with tending wild stands of wheat and barley notice something important. In this stable, warmer climate, seeds planted deliberately can be counted on to sprout and mature with a regularity that would have been unthinkable in the Younger Dryas chill. The risk calculus shifts. Investing labor in sowing and weeding starts to make sense. Those first hesitant rows of cultivated plants are as much a bet on the new climate regime as they are on human ingenuity. On other continents, similar experiments unfold in parallel. In China, rice and millet. In Mesoamerica, squash and maize's wild ancestors. In the highlands of New Guinea, taro and bananas. Each domestication event is a localized response to a global opening. The Holocene's gentler, more forgiving baseline. Psychologically, too, there is a shift. The grandparents of this age grew up with the stories of ice, fire, and vast floods still raw on their tongues. For their grandchildren, those tales are true, but distant, like our own narratives of world wars. Their lived reality is one of gradual, comprehensible change. A tree line moving a little higher. A river cutting a slightly different meander. The memory of the universe turning on them like a wild animal recedes, replaced by a cautious trust that the sun will come when it's supposed to. The rains will roughly match expectations. In that trust, something dormant begins to stir. Ideas for shaping the world rather than just surviving it take root. Instead of endlessly adapting to the landscape's whims, humans start to entertain the opposite, making the landscape adapt to them. By planting, by building, by herding. The Holocene is not just a new chapter in Earth's climate history. It is the stage on which a species, still haunted by unremembered catastrophes, finally has the breathing space to try something audacious. Civilization. In the soft dawn of the Holocene, the Near East does not yet know the words field or farm, but the seeds of both are already underfoot. The Fertile Crescent, an arc of hills and river valleys from today's Israel and Jordan through Syria, Turkey, and into Iraq, is waking up from the Younger Dryas like the rest of the world. Snow lines retreat up the mountains. Winters are still chilly, but no longer murderous. On the slopes and in the valleys, something remarkable happens. Grasses that once grew thinly now ripen in great, golden sheets. These are wild einkorn and emmer wheats, barleys, oats, a chaos of slender stalks heavy with grain. For generations, hunter-gatherers have visited these stands seasonally, cutting seed heads with flint sickles, beating them into baskets, and moving on. They know which patches ripen earliest, which tolerate shade, which bounce back after grazing. The landscape is a living pantry mapped in memory. But memory also holds something else, the story of a world that can turn. The people now walking these hills are not so far removed from the Younger Dryas that its scars have vanished. Their elders still speak of the cold time, of years when game failed and plants withered, of migrations forced by failing springs. Even as the climate stabilizes, that sense of fragility lingers like a low-grade fever. Yes, the world seems kinder now, but they know it can be cruel. In that psychological climate, the idea of depending entirely on the wild feels less romantic than precarious. Archaeologists trace the first steps toward farming in subtle changes. In Natufian sites predating full agriculture, we find heavy stone mortars and pestles for grinding seeds, as well as sickle blades with a distinctive sheen. Sickle, gloss, from repeated cutting of stalks. Habitation sites become more substantial. Stone-lined pits, semi-permanent huts, cemeteries indicating emotional investment in particular places. These people are still mobile, but less so. They are tethering themselves, lightly at first, to favored locales. Then, after the Younger Dryas, the tether tightens. Some groups in the Fertile Crescent begin doing something audacious: planting. At first, it may be as simple as shaking out collected seeds on ground near camp, or deliberately trampling and disturbing soil where they've seen plants thrive. Over time, they notice that seeds from certain plants, the ones with larger grains or that ripen more predictably, produce offspring with similar traits. Unwittingly, they are performing selection. Wheat varieties with tougher rachises, the bit that holds seeds to the stalk, are favored because they don't shatter in the field and can be harvested more easily. Slowly, through countless hands and seasons, wild grasses become domesticated crops. Alongside the plants come animals. Herds of wild goats and sheep graze the same slopes. Hunters know their habits intimately. Which paths they favor, where they lamb, how they respond to threat. It is a short conceptual step from stalking and spearing them to penning a few, culling some, and breeding others. Early attempts are clumsy. Many animals escape or die. But in certain villages, the balance shifts. Bones in the trash show a skewed age and sex profile. More young males, fewer older females. Signs of managed herds rather than purely wild hunts. Why take on such effort? Hunting and gathering in a rich environment can provide varied diets and ample leisure. Agriculture, in contrast, is backbreaking. Fields must be cleared of stones, plowed or at least scratched, sown, weeded. Harvest is labor-intensive. Crops fail. Stored grain invites pests and thieves. Early farmers are shorter, with more signs of illness and stress in their bones than their forager ancestors. The answer may lie less in abundance than in control. For people whose cosmology has been shaped by a universe that once nearly erased them, control, even partial, even illusory, is intoxicating. Fields represent an attempt to wrap predictability around food. If the herds move strangely one year, if the forests burn or rivers flood, grains in a granary are a buffer. Terraces on a hillside are not only engineering feats, they are psychological bulwarks against randomness. A goat herd in a stone enclosure is not just meat on the hoof. It is continuity you can touch. There is also safety in numbers. Sedentary life and surplus production allow larger communities to form, which can better defend against raids, share labor, and buffer individual misfortunes. But that safety comes with strings attached. Settle down, and you inherit new vulnerabilities. to crop diseases, to droughts that now threaten not just one season's hunt, but next year's seed, to hierarchies that emerge around the control of stored food. In this light, agriculture is not a simple advance, but a bargain. You trade mobility for stability, dietary breadth for caloric reliability, egalitarian bands for more stratified villages. Underneath those trade-offs hums an emotional logic forged in catastrophe. If the sky can fall, build something that might stand when it does. A field of wheat, a stone granary, a cistern carved into bedrock. These are bets placed against geological time, small human attempts to smooth out the spikes and plunges that their grandparents endured. We can see hints of this anxiety even in mythic gardens. Eden, in the Hebrew Bible, is a place where food grows without toil until a transgression leads to exile, after which humans must wrest bread from reluctant soil by the sweat of your brow. In Sumerian tales, the gods initially farm for themselves, then create humans as laborers to take over the tedious work. Both narratives recognize farming as burdensome, yet somehow inescapable, a condition imposed whether by divine decree or by environmental necessity. It is tempting to view the rise of agriculture as inevitable once conditions permitted it. But inevitability is a story we tell backward. At the moment it began, it was one option among many. A bet placed by frightened, clever primates on a planet that had proven itself erratic. They did not choose farming because it was easy or obviously superior. They chose it because, in a world where ice and fire had once rewritten the rules overnight, they wanted at least one part of their lives to answer to their hands instead of the sky. By the time fields of wheat ripple in the valleys and goat bells jangle on terraced hills, another idea has taken hold. If you are going to stay, you might as well build. The first cities rise not all at once, but as accretions of mud brick and memory, their walls literally layered with choices made over centuries. Beneath their streets lie older hearths, older burials, older dreams of safety. On a low mound near the Jordan River stands Jericho, one of the earliest and most enigmatic. Around 9,000 years ago, what began as a cluster of houses swells into something more. Mud brick dwellings huddle together, sharing walls. Between them, narrow alleys twist, channeling voices and smells. Bread baking in dome ovens, the sharp tang of fermenting grain beer, the acrid bite of hearth smoke that never quite clears. Goats bleat, children shout, potters' wheels hum. Life is now lived in close quarters, the individual family fire absorbed into a larger, ceaseless heat. Then comes the wall. At Jericho's edge, people stack stone upon stone, then mud brick atop that, until a formidable ring encircles the town. A tower rises inside it, stone steps spiraling upward into a dark interior. Archaeologists debate why. Defense against enemies. Protection from flash floods off the surrounding hills. A communal project binding residents together in shared labor. Whatever the reason, the psychological effect is undeniable. Inside those walls, there is an us, a defined space separate from the wild beyond. Further north and east, in what is now central Turkey, another mound swells. Çatalhöyük. Around 7500 BCE, this settlement becomes a honeycomb of plastered rooms, accessible not by streets, but by rooftop ladders. Houses press so tightly together that to move through the town, you walk over roofs, not between walls. Inside, whitewashed plaster glows in the firelight. Bulls' heads, bucrania, are set into walls, their horns protruding. Paintings of hunting scenes, vultures stripping flesh from headless corpses, and geometric patterns pulse in red and black. Here, the dead lie beneath the floors of the living. Skulls are sometimes removed, modeled in plaster and kept as relics. Daily life and ancestral presence are collapsed into one space. Outside, trash heaps grow thick with animal bones, broken tools, ash. The air hums with flies in summer. This is urban density before streets and sewers, an experiment in living many lives on top of one another. In both Jericho and Çatalhöyük, and later in Uruk and its sister cities, we may be seeing not just novel invention, but reconstruction. The very act of building densely, stacking homes, erecting walls, carving towers, suggests an inherited sense of what a proper human place feels like. Perhaps this template came purely from long observation of villages scaling up. Or perhaps, as some fringe but intriguing theories suggest, there lingered vague echoes of older coastal settlements now underwater, of arrangements that felt right because they had been tried before by cultures wiped from the visible record. By the time Uruk rises on the Mesopotamian plain around 4000 BCE, the city dream has become bolder. Here the sensory overload is intense. The clatter of potters' kilns and copper furnaces, the slap of wet clay as bricks are molded and stacked, the calls of merchants in crowded markets, the muttered incantations of scribes pressing wedge-shaped signs into tablets. Ziggurats, stepped temple towers, climb above the flat roofs, their glazed surfaces catching the sun. Canals thread through and around, carrying water and traffic, their banks lined with warehouses and docks. Uruk's walls, later mythologized in the Epic of Gilgamesh, are said to encircle the city like a stone horizon. To walk atop them is to see a clear division. Within, order, temples, palaces, houses aligned in districts. Beyond, the unpredictable fields and steppe, the domain of nomads and wild things. The physical barrier doubles as a mental one, separating a world governed by human rules from the caprices of nature. Inside, the stories change too. The raw fright of ice, fire from the sky, and drowning continents has been digested into pantheons and rituals. The gods still control storms and floods, but these are now riverine. The Nile's predictable cresting, the Euphrates' occasional rage, not planetary resets. Texts from this era still reference a primordial deluge, but as something that happened in the deep past, before kingship descended from heaven, before cities were founded. It becomes a mythic prologue, a cosmic backstory against which the drama of human laws and royal lineages plays out. In temple schools, apprentices learn lists of gods, offerings, contracts, not calculations of comet orbits. Scribes record eclipses and unusual celestial events, but increasingly as omens relating to dynastic fortunes rather than as existential threats. The sky is once again a language of politics and prophecy more than survival. The living fear locusts, invasions, and droughts far more than another ice age, whose tail end their ancestors endured, but they do not remember. Yet traces of the old terror persist in the architecture itself. Ziggurats elevate sacred spaces above the floodplain, their platforms literal high ground against rising waters. City planners orient main streets and temple axes not only to cardinal directions and solstices, but sometimes to auspicious stars, perhaps relics of an earlier obsession with tracking the heavens. Massive grain stores, ringed by walls, stand as insurance against failed harvests. Law codes carve stability into clay. Here, if you steal, this happens. If you injure, that. On a planet that once lurched unpredictably, brick and law are attempts to pin reality down. Civilization, in this sense, is not just a tech tree climbing from stone tools to smartphones. It is a psychological project. overriding the memory of skyfall with routines, institutions, and skylines. In crowded streets, under the shadow of walls and temples, children grow up believing that the biggest forces in their lives are kings and priests, harvests and wars. The idea that once an unseen rock shredded the atmosphere and tipped their world into a 1,000-year winter is buried deep, if it is there at all. But even as fire and ice recede into legend, they leave imprints, faint, like old trauma in a healed mind. The need for walls, the fixation on high ground, the compulsion to legislate against chaos. The first cities remember stone, how to shape it, stack it, live within it. What they forget, gradually and by design, is why their ancestors first dreamed of such enclosures. Because once, the universe itself felt like an open field with no shelter, and they swore, consciously or not, never to be so exposed again. In the narrow lanes of the first cities, daily life runs on the small clocks of sun and stomach. Dawn's light over the walls, the noon glare, the cool of evening. But above the mud brick and bustle, another clock turns, vast and silent. For reasons both practical and haunted, certain people start watching it with an intensity bordering on obsession. These are the priest astronomers, the timekeepers of the cosmos, whose gaze never quite leaves the sky that once, according to their oldest stories, turned against them. On the flat plains of Sumer, the horizon is a clean, unbroken line. There are no high hills to hide the rising and setting of celestial bodies. Ziggurats thrust upward from this level world, stair-stepped mountains of baked brick. At their summits, small shrines open to the air, perfect platforms for observation. Night after night, scribes with reed style and clay tablets note the positions of bright stars and wandering planets. They record when certain constellations first appear before dawn, when the moon fattens and thins, when strange omens, a red glow, an unexpected eclipse, mark the heavens. Officially, their task is to serve the gods, to read divine will in the motion of the firmament, to set the dates of festivals, to ensure that sacrifices are made at the proper times. They build calendars that align lunar months with the solar year, intercalating extra days when necessary to keep sowing and harvest in sync with the seasons. Their system of dividing hours into 60 minutes and circles into 360 degrees is not mere convenience. It is an attempt to impose numerical order on the sky. Across the desert, along the Nile, Egyptian priests do something similar in stone. The river dictates their seasons: inundation, emergence, harvest. But the sky refines the schedule. The heliacal rising of Sirius, the brilliant star they call Sopdet, just before dawn heralds the flood, arriving with uncanny regularity. Temples and even entire city plans are oriented so that on specific days, the sun's light spears down corridors, illuminating inner sanctums in calculated bursts. The Great Pyramids of Giza, so often thought of as tombs alone, are frozen dialogues with the heavens. Their sides almost perfectly aligned to the cardinal directions, their shafts pointing toward circumpolar stars that never set. The imperishables. In Mesoamerica, long after Sumer and Egypt have risen, flourished, and declined, Maya priest astronomers track Venus with a devotion that borders on mania. They compile tables of its risings and settings spanning centuries, correcting for subtle irregularities. Their calendars, interlocking cycles of 260 days, 365 days, and longer counts reaching thousands of years, map time with a granularity and depth unmatched anywhere else in the ancient world. Their pyramids and observatories, like El Caracol at Chichen Itza, frame specific solar and planetary events in stone windows and staircases of light and shadow. The official explanation is, again, religious and agricultural. Knowing when the rains will likely come, when to plant, when to expect seasonal storms or dry spells, can mean the difference between feast and famine. Venus is tied to war and sacrifice. Its appearances shape human calendars of violence and offering. Eclipses must be predicted so they can be ritually managed, their terror defanged. Yet beneath these surface needs, a deeper motive may be at work. A collective, half-buried fear that the sky can, without warning, do more than dim the sun for an afternoon or shift the monsoon by a few weeks. Somewhere in their inherited mythologies, there is the memory, blurred but potent, of fire falling, of darkness that lasted not hours but years, of stars gone wrong. Imagine a watch on top of a ziggurat in Uruk around 2000 BCE. The city below is asleep or murmuring in courtyards. Above, the sky is a vast bowl pricked with light. A priest stands with a simple sighting tool, aligning it with a familiar star near the horizon. It rises where it should. He makes a mark on a tablet, satisfied. But there is also in him a quiet, superstitious relief. Nothing new, nothing unexpected. The patterns hold. Then, one night, a bright stranger appears. A comet, perhaps, its tail faint at first, then lengthening. To the untrained, it is simply beautiful or ominous. To the priest, it is the thing his entire profession dreads: a deviation. Stories rush up from the deep cultural well. Star with hair, sky serpent, world ender. He notes its position obsessively, night after night, calculating its path, matching it to omens in older texts. Will it pass harmlessly? Or is this the harbinger of the kind of chaos his ancestors only hinted at in parables of floods and burning? In this light, ancient astronomy looks less like idle curiosity and more like intergenerational vigilance. Calendars are not just tools for planting. They are early warning systems, solstices and equinoxes, precession, the slow wobble of Earth's axis that shifts which stars mark true north and which constellations host the sun at the solstices. These are not abstract cycles. They are the deep workings of the machine that once hiccuped catastrophically. To notice that the sun rises a hair's breadth further along the horizon than expected is to imagine that maybe, this time, the deviation will not stop. Of course, over centuries of stability, the watchfulness accumulates theology. The idea that star patterns could warn of another cosmic ambush hardens into belief that they predict the fates of kings, the outcomes of battles, the fortunes of crops. Astrology, in its oldest forms, is arguably a misapplied survival instinct. The urge to tie everything on Earth to what happens overhead. Because once, what happened overhead nearly deleted everything on Earth. From our vantage point, we can reconstruct orbital mechanics, simulate comet orbits, and calculate impact probabilities with cold precision. We know that solstices drift because of axial precession, and that comets follow ellipses, not whims. Yet when we see how painstakingly our ancestors tracked those motions, chiseling them into stone alignments, encoding them in calendar wheels and priestly almanacs, we can suspect that they, too, were motivated by more than piety and planting. In their vigilance, there is an echo of an older terror. A sense that the universe is not a backdrop but an active player, one that has, in living memory of the species, if not of any individual, thrown a punch hard enough to reshape continents and erase beasts. Watching the sky, measuring its cycles, giving names and stories to its deviations is how they tried to make a truce with that memory, to turn an old wound into a timetable. So that if the heavens ever stirred that way again, someone, somewhere on a temple top, would would be the first to see it coming. As the first calendars locked the sky into patterns and the first cities walled chaos out, another project unfolded in parallel, giving names and faces to the forces that had once rampaged unchecked. The great pantheons of the ancient world, Sumerian, Egyptian, Greek, Mesoamerican, look, on the surface, wildly different. Different animals, different costumes, different stories. But look at their job descriptions, and a strange familiarity emerges. In each, there are lords of the sky and storm, rulers of the sea, keepers of the underworld, tricksters who steal or bend divine fire. It is as if humanity, scattered across continents, drafted the same cast list to play different roles on different stages. In Sumer, the high god Enlil wields the wind and the storm. He is capricious, powerful, easily angered. It is Enlil who, annoyed by the clamor of humanity, calls for their extermination by flood. When the waters come, they are not gentle rains, but howling tempests, the kind that would peel roofs and trees alike. Beneath him, the sea deity Enki, Ea, lord of the freshwater abyss, plays the contrarian, warning Utnapishtim, finding loopholes in decrees, preserving a remnant of life. The cosmic drama between destruction from above and salvation from below is written into their very domains. Shift westward, and the Greeks tell of Zeus, king of the gods, who commands thunder and lightning from his perch on Mount Olympus. His anger can split oak trees, topple ships, incinerate mortals. At sea, Poseidon rages with earthquakes and storms, his trident churning waves that can swallow islands. When the mythic flood of Deucalion is sent to purge a corrupt humanity, it is Zeus's will and Poseidon's water that execute the sentence. Meanwhile, Prometheus, the trickster benefactor, steals fire and knowledge for humans, earning eternal punishment. Again, we see a split. Overwhelming celestial force on one side, a rebellious ally on the other. In Mesoamerica, rain and storm are personified in gods like Tlaloc among the Aztecs, or Chak among the Maya, beings with goggle eyes and fanged mouths, wielding lightning axes. They bring the life-giving rains, but also hail, thunder, and flood. Their displeasure is feared, their altars stained with offerings to keep the balance. Quetzalcoatl, the feathered serpent, plays a different role. Culture bringer, teacher of agriculture and calendar, sometimes savior after previous world destructions. In some versions of the Yaur, mythic cycles. Earlier worlds end in water or fire, with only a few survivors guided by gods like him to begin again. Egypt's pantheon, shaped by a more predictable river but no less aware of disaster, splits authority between sky and water too. Ra sails the solar boat across the sky, his daily journey crucial to light and warmth. When humanity rebels, he sends the lioness Sekhmet to slaughter them, a bloody near-extinction event only halted by trickery. Meanwhile, Nun, the primeval watery chaos, always threatens at the edges. The ordered world is an island held above this abyss. The Nile itself has a divine aspect. Hapi, whose too low or too high floods can mean starvation or destruction. Viewed through the lens of the Younger Dryas and its aftermath, these deities look less like arbitrary inventions and more like personified memories of specific kinds of terror. Storm gods and sky kings are the faces we put on murderous weather and fire from above. Sea lords are the avatars of rising waters, storm surges, and drowned coasts. Underworld judges and death gods preside over the sudden, mass mortality that follows famine, plague, and freezing. Trickster saviors, Enki, Prometheus, Quetzalcoatl, stand in for the rare, cunning forces or individuals that preserve knowledge and life through catastrophe. In this reading, the great flood gods are not just metaphors. Enlil's wind and deluge, Zeus's storm clouds, Tlaloc's torrential wrath capture, in language of personality, what it felt like to be on the receiving end of a climate system flipping state. When the Younger Dryas struck, thunderstorms and blizzards were not mere inconveniences. They were existential. A bad year could mean no large game, failed wild crops, iced-over rivers. A series of such years, amplified by strange skies and unfamiliar cold, would feel like being targeted by an intelligence. Not random misfortune, but deliberate attack. Humans are wired to see agency. We look for faces in clouds, intention in accidents. In a world where landscapes themselves seem to rise and drown, where ice walls collapsed and unleashed floods that erased valleys, that tendency would be irresistible. Naming a storm Enlil, or a flood the anger of Zeus, does more than decorate it with character. It gives the sufferer something to argue with, plead with, bargain with. You cannot sue an ocean or negotiate with a jet stream. You can, in theory, appease a god. The same psychology frames the tricksters. Enki leaking the flood plans through a reed wall, Prometheus stealing fire and perhaps knowledge of crafts, Quetzalcoatl bringing corn and the count of days. These are stories about forces, maybe very human forces, that subvert cosmic cruelty. A leader who moved his people to high ground ahead of a flood, or who preserved seeds and skills through a long winter, could, over generations, be mythologized into a semi-divine figure, the one who outsmarted heaven. In a myth, that cunning is externalized into an immortal character. In history, it might have been a clan elder, a wandering sage, a group of refugees. There is, of course, a danger in stretching this interpretive net too far. Not every storm myth hides a reference to the Younger Dryas. Not every angry god is a stand-in for comet fragments. Cultures also project social dynamics upward. Kings make gods in their own image, vengeful and grandiose. Oppressed peoples dream of gentler deities. Religion is as much about human politics as about weather. Yet the recurrence of certain portfolios, Stormbringer, Sea Lord, Underworld Judge, Cunning Benefactor, across distant civilizations hints at a shared template deeper than any one culture. Emotionally, this template serves a double purpose. It lets us place blame. The flood came because Enlil was angry, which is easier to live with than a random cluster of icy rocks happened to intersect our orbit. And it gives us someone to beg. Sacrifices, prayers, rituals. These are attempts to renegotiate a contract that was once broken without warning. If you pour enough beer on the temple floor, if you burn enough incense, maybe the sky will remember its calmer face and wear it longer. In that sense, gods of sky and deep are less about controlling the universe than about coping with the memory that it is not, and never has been, under our control. They are masks we hang on storms and seas so that, when they rage, we can feel we are in conversation with something, not just being battered by blind physics. Underneath their jeweled crowns and serpent headdresses lies a simpler, more frightened impulse: to make meaning out of the time when the world itself seemed to turn against us, and to hope that, by telling those stories well enough, we can keep it from happening again. Long before internet forums and late-night documentaries, the idea of a lost, advanced civilization haunted human imagination. It surfaces in different guises: Atlanteans, Lemurians, people of Mu, the Golden Race. But the outline is familiar. Once there was a world more refined, more harmonious, perhaps more technologically or spiritually advanced than our own. Then, through hubris or cosmic misfortune, it vanished beneath the waves. What remains are scattered stories, suspicious ruins, and a stubborn sense that history is missing a chapter. The most influential version of this story comes from a single Greek philosopher, Plato. In his dialogues, Timaeus and Critias, written in the 4th century BCE, Plato has his characters recount a tale supposedly passed down from Egyptian priests to the Athenian lawgiver Solon, then to Solon's descendants, then to Plato's own grandfather. According to this chain, beyond the Pillars of Heracles, the Strait of Gibraltar, lay a great island, Atlantis, larger than Libya and Asia Minor combined. Its people, Atlanteans, were seafarers with impressive engineering. Concentric rings of canals, around their capital, temples sheathed in metals, an organized army and navy. At first, Plato says, they were virtuous, guided by divine ancestry. Over time, they became greedy, imperial, corrupted by power. When they attempted to conquer the Mediterranean, Athens, in a strangely anachronistic role, stood against them and prevailed. Then, as if in moral punctuation, disaster struck. In a single day and night of misfortune, violent earthquakes and floods swallowed Atlantis, and the sea where it lay became muddy and impassable. Plato dates these events to about 9,000 years before Solon's visit to Egypt, placing Atlantis's fall around 9,600 BCE. That is unnervingly close to the end of the Younger Dryas, when sea levels were surging and coastlines were being redrawn. Some enthusiasts have taken this numerical overlap as proof that Plato preserved a true geological memory. Others caution that ancient numbers are often symbolic, that Plato was likely constructing an idealized narrative to make philosophical points about ideal states, hubris, and decline. Mainstream classicists overwhelmingly see Atlantis as allegory, not reportage. Plato never again treats it as history. No other Greek source independently corroborates the tale. Its geography is fuzzy. Its social structure is oddly tuned to Plato's own political obsessions. To demand that Atlantis be proved in the literal sense, found as a specific island with matching canals, is to miss its likely original purpose. And yet, the timing and imagery refuse to lie entirely flat. Around the world, between roughly 12,000 and 7,000 years ago, post-glacial sea level rise did indeed drown continental shelves in low-lying coastal plains. Doggerland in the North Sea, the Black Sea Basin, Sundaland in Southeast Asia, expanses off India, the Americas, and the Mediterranean, all experienced real land loss on a scale that would have birthed legends. Communities who had settled fertile river mouths found their villages repeatedly chased inland. Entire island chains emerged or vanished within human memory. It is not difficult to imagine that seafaring peoples along those coasts, perhaps more skilled and socially complex than interior foragers, developed maritime trading cultures. Their harbors, storehouses, and shrines would have hugged what was then the shoreline. When the ocean advanced, those hubs would have been precisely what went under first. Survivors retreating to higher ground or inland refugees might carry stories of a world before, in which their ancestors ruled the sea, now lost beneath encroaching waves. Other lost land myths echo this pattern in different keys. In the 19th century, European scholars, puzzled by similarities between lemurs in Madagascar and India and certain fossil records, proposed a sunken landmass, Lemuria, in the Indian Ocean, where such creatures might have evolved and dispersed. The biological problem was later solved by plate tectonics and continental drift, but the romantic notion of a drowned continent stuck. Occultists and theosophists grafted human civilizations onto it, imagining wise Lemurians whose continent sank in catastrophe. Similarly, Writer James Churchward popularized Mua in the early 20th century, claiming inspiration from dubious Nakal tablets. He placed this hypothetical lost civilization in the Pacific, its remnants supposedly visible in Easter Island statues and Mesoamerican monuments. Geology offers no support for a vanished Pacific supercontinent in the relevant timescale. But the appeal of a sophisticated culture wiped clean by flood or quake proved resilient. Beyond named continents, many cultures preserve vaguer images of a golden age before the fall. Hesiod, in Greek tradition, speaks of a golden race of humans who lived like gods, free from toil and sorrow, before being replaced by lesser races after successive declines. Indian texts describe Satya Yuga, the age of truth, followed by darker ages in cyclical sequence. In some readings, these are purely moral metaphors. In others, they hint at a dim memory of pre-cataclysm societies by later peoples living in more constrained, harsher conditions. What if we read all these stories, not as blueprints, but as smoke? Atlantis, Lemuria, Mu, the Golden Age. Each is, in its origin, probably a mixture of philosophical invention, misunderstood geology, and cultural yearning. Yet their persistence and recurrence suggest they resonate with something deeper than simple escapism. We humans are unique in that we can sense the vastness of time and our own brevity within it. Standing on a coast, looking at the sea, many have felt that eerie hunch that under those waves lies more than sand and fish. Perhaps cities, roads, an entire chapter of us. The Younger Dryas and its aftermath give that hunch a context. We now know that the end of the last ice age was not a smooth glide into our current world, but a series of jolts. We know that coastal regions, prime locations for early complex societies, were repeatedly inundated. We know that human groups moved, adapted, and in some cases, vanished. Against this backdrop, Plato's phrase, "in a single day and night of misfortune," sounds less like pure hyperbole and more like a compressed literary echo of generations watching the ocean take and take. The aim, then, is not to pin Atlantis to a GPS coordinate or resurrect Lemuria's hypothetical flag. It is to recognize that the idea of a pre-flood high civilization is not an accidental quirk of Western storytelling, but a recurring human dream across cultures. That dream may be powered partly by psychological desire, a wish to believe we are heirs to something grander, as well as by genuine, if distorted, memories of coasts and cultures lost to rising seas. In acknowledging both, we walk a narrow path. On one side lies credulous fantasy. On the other, a sterile insistence that nothing of importance happened before our current data sets. Between them runs a more interesting possibility, that our myths of drowned golden ages are neither literal maps nor empty fables, but the way a species with poor long-term memory nonetheless tries to remember that, once, the world it knew drowned, and that what we call the beginning might, in truth, be a restart. As our understanding of real ancient cataclysms deepened, a curious thing happened in the modern imagination. Instead of putting our fears to rest, science gave them new costumes. Old terrors of floods, sky fire, and sudden endings slipped into the language of planets and orbits. Few examples show this more clearly than Nibiru, a word that began as a precise Mesopotamian astronomical term and was reborn millennia later as a phantom world destined to end us. In cuneiform tablets, Nibiru, or Nebiru, has a sober technical meaning. Babylonian astronomer priests used it to describe a crossing point in the sky, often associated with Jupiter, the king planet, or with a specific part of the ecliptic where celestial paths intersect. In the Enuma Elish, the Babylonian creation epic, Marduk receives Nibiru as one of his titles. It is the station that holds the crossing of heaven and earth, a cosmic reference point of order, not chaos. Far from being a rogue world on a wild orbit, Nibiru was, originally, a marker of stability in carefully observed star catalogs. Enter the late 20th century, an era of Cold War tensions, UFO enthusiasm, and growing skepticism toward official narratives. Into this ferment stepped Zecharia Sitchin, a journalist and amateur scholar who in 1976 published The 12th Planet. Reading Mesopotamian myths through a radically literal lens, he proposed that the Anunnaki, Sumerian gods, were actually extraterrestrial visitors from a real planet named Nibiru, moving on a vast, elongated orbit around the sun. Sitchin wove an intricate story. Nibiru, he claimed, takes 3,600 years to complete a single orbit, arcing from the outer dark into the inner solar system. Each passage brings its inhabitants close enough to Earth to interact with us. In his telling, these beings genetically engineered humans as a labor force, seeded early civilizations, and were responsible for great upheavals, including global floods. The original meaning of Nibiru as a celestial crossing point was reinterpreted as the literal crossing of a hidden planet through our neighborhood. A crossing that, he implied, had previously triggered cataclysms and might do so again. Mainstream Assyriology and astronomy rejected Sitchin's ideas. Scholars pointed out that his translations of Sumerian and Akkadian were idiosyncratic at best, often flatly wrong. Astronomers noted that a massive planet on such a wild orbit would leave clear gravitational fingerprints in the motions of known planets. Fingerprints no one could find. Yet, Sitchin's narrative resonated. It offered answers where orthodox history had only question marks, recasting dusty myths as eyewitness reports of spacefaring gods. It said, in essence, you are the product of a cosmic drama, and it's not over. Then came a date, December 21st, 2012. The Mayan long count calendar's 13th Baktun, a roughly 5,125-year cycle, was due to turn over on that day. Scholars of Maya culture saw it as a calendar reset, a time of renewal, like odysseys on an odometer clicking from 999999 to 00. But popular writers, New Age thinkers, and conspiracy theorists spun it as an end times marker. A planet on a long, mysterious orbit and a looming, misunderstood calendar rollover made a potent combo. Nibiru was plugged into 2012 like a missing puzzle piece. On message boards and in breathless documentaries, claims proliferated. Nibiru, they said, was inbound, hidden from public view by NASA and world governments. Its gravitational pull would flip Earth's poles, trigger mega-earthquakes, unleash super tsunamis. Photographs of lens flares near the sun, ordinary image artifacts, were trotted out as leaked images of the approaching world. Any newly discovered comet or distant object became, briefly, a stand-in for the mysterious destroyer. The ancient flood myths and Younger Dryas-style cataclysms echoed faintly in the background, repackaged. Instead of angry gods or shattered comets, the new culprit was a planet whose periodic passage reset Earth's story. Old anxieties, the sense that our current world is just one chapter between wipes, found a new expression that felt, superficially, more scientific. A rogue planet slotted neatly into the framework of orbital mechanics, even as it defied all observation. Telescopes, however, remained stubbornly silent. In the years leading up to 2012, professional and amateur astronomers alike scanned the skies. Surveys like the Wide Field Infrared Survey Explorer, WISE, mapped the entire sky in infrared light, sensitive to the heat signatures of large, cold objects. Planet-sized bodies closer than the outer fringes of the solar system would have been obvious. None appeared. Planetary orbits showed no mysterious perturbations. No hidden giant was tugging on Neptune or warping comets in a way that matched Nibiru's proposed path. NASA, usually reticent about engaging with fringe theories, found itself fielding a barrage of terrified questions from adults and children about the supposed incoming planet. Astrobiologist David Morrison posted videos calmly explaining orbital dynamics. That if a planet big enough to end civilization were on course for a 2012 rendezvous, it would have been one of the brightest objects in the sky for years. You wouldn't need a space agency to point it out. You could see it from your backyard. December 21, 2012, came and went with mundane sunrises and sunsets. No rogue planet, no pole shift, no global deluge. For some, this was a relief and a quiet end to the story. For others committed to the narrative, the dates shifted, explanations morphed. Calculations were off. Interventions by benevolent beings averted disaster. Nibiru was delayed. The phantom planet proved as adaptable as any mythic entity. Why did it catch on so fiercely? Part of the answer lies in distrust of institutions, of official stories. But beneath that lies something older. Our species carries, in its bones and stories, the knowledge that the sky has killed before. We now have geological evidence that comets and asteroids have reset life multiple times, that ice ages can snap and floods can redraw the map. In that context, a rogue planet is less a wild fantasy than a miscalibrated metaphor. A way to focus diffuse dread into a single, nameable threat. Nibiru hijacked the flood, not because anyone unearthed a tablet predicting a specific planet, but because the human psyche is quick to graft ancient fears onto any plausible-sounding vehicle. In the ancestral imagination, gods hurled storms. In the post-Apollo imagination, unseen worlds do. The mechanism changes. The unease endures. Contrasting Nibiru's mythic power with the silence of telescopes is instructive. Our instruments tell us that no such planet is lurking on a collision course. Our data say that the real dangers are smaller, subtler. Undetected near-Earth asteroids, long-period comets, climate feedbacks we ourselves are driving. Yet the story of Nibiru reveals an important truth. Even in an age of satellites and supercomputers, we are still the descendants of those who watched fire fall and water rise. And we are still looking up, half expecting the sky to announce, in some dramatic, undeniable way, that our lease on this world has come due. Nibiru may be a phantom, but the cosmos is not suddenly safe, because one imagined monster evaporated. If anything, clearing away fictional threats sharpens our view of the real ones. For our ancestors, the danger was abstract, fire from the sky, gods in storm clouds. We, for the first time in history, can put names, sizes, and orbital elements to many of the things that could ruin our day, our century, or our species. They are called near-Earth objects, asteroids and comets whose orbits cross or come close to ours. As of now, astronomers have cataloged more than 30,000 of them. Most are small, boulders tens of meters across that would burn up or explode high in the atmosphere. A few are larger, from 140 meters up to several kilometers, big enough to devastate regions, continents, or the entire globe if they hit. The good news is that we've already found the vast majority of the truly apocalyptic ones. Surveys suggest that nearly all near-Earth asteroids larger than about 1 kilometer have been detected and tracked. None is on a collision course with Earth for at least the next century. The kind of event that killed the dinosaurs, an object about 10 kilometers wide slamming into shallow ocean, remains possible on multi-million-year timescales. But it is not lurking just around the corner. The less comforting news lies in the middle range. Objects between about 50 and 300 meters wide, big enough to obliterate a city or cause regional catastrophe, are far more numerous, and many remain undiscovered. Their small size makes them faint until they are quite close. Some approach from sunward, hidden in our star's glare until they're nearly upon us. These are the rocks that keep planetary defense experts up at night. We've had previews. In 1908, over the remote taiga of Tunguska, Siberia, a roughly 50-meter object, probably a stony asteroid, entered the atmosphere and exploded at an altitude of 5 to 10 kilometers. The blast flattened some 2,000 square kilometers of forest, knocking down an estimated 80 million trees. Witnesses reported a fireball brighter than the sun, a shock wave that shattered windows hundreds of kilometers away, and nights so bright in Europe that people could read outdoors. Had the object arrived a few hours later, Earth's rotation would have placed a city, not wilderness, beneath it. In 2013, a smaller reminder came without warning over Chelyabinsk, Russia. A 20-meter asteroid approached from the direction of the sun and detonated high in the atmosphere with about 30 times the energy of the Hiroshima bomb. The shock wave blew out windows across the city, injuring over 1,500 people with flying glass. No one died. But the dashcam videos of the incandescent streak and the delayed boom drove home an unsettling fact. Even in the age of space telescopes, the first sign of some threats may be a flash in the sky. To reduce those surprises, astronomers have mounted systematic searches. Projects like Linear, Pan-STARRS, and the Catalina Sky Survey sweep the sky night after night, comparing fresh images to previous ones to spot moving points of light. Upcoming missions, like NASA's NEO Surveyor Space Telescope, aim to hunt for dark, heat-emitting asteroids from an orbit that avoids the sun glare problem. Bit by bit, the catalog fills in. Orbits are calculated, risk levels assigned, and potential impact corridors centuries into the future mapped. Knowing is the first step. The second, unthinkable to all previous civilizations, is doing something about it. The early 21st century has seen the birth of planetary defense as an applied science. Instead of waiting passively, we are beginning to experiment with ways to nudge dangerous objects off course. In 2022, NASA's DART mission deliberately crashed a small spacecraft into a modest asteroid moonlet, Dimorphos, to see if its orbit could be measurably altered. It was. The impact shortened the moonlet's orbital period around its parent by about half an hour. It was a tiny push on a tiny target, but it proved a crucial point. Kinetic impactors, essentially high-speed cosmic billiard shots, can, given enough warning time, change an asteroid's path. Other concepts sit on the drawing board. A gravity tractor, a massive spacecraft parked near a threatening asteroid using its own slight gravitational pull, applied over years, to tug the rock into a safer orbit. Focused solar energy or ion beams to vaporize surface material, turning the outgassing into a thruster. In extreme cases, nuclear devices detonated at a distance, using radiation pressure and ablation, not Hollywood-style shattering, to deflect rather than blow apart. All of these approaches share two requirements: early detection and political will. The physics of deflection favors long lead times. A nudge applied decades in advance can translate into a miss of thousands of kilometers. Discover a dangerous object only months before impact, and no realistic intervention is possible. Meanwhile, funding for planetary defense, though growing, remains tiny compared to other expenditures. We spend more each year on cosmetics or streaming services than on systematically finding and preventing the few events that could end civilization. Emotionally, this is sobering. For all our satellites and smartphones, we are still only just learning to see the bullets in the cosmic shooting gallery we've always lived in. Our ancestors sent their fears upward as prayers. We send probes and proposals. Yet underneath, the stakes feel eerily familiar. Somewhere between the firestorm of Tunguska and the silent precision of an infrared survey telescope lies the same basic question that haunted those who watched the Younger Dryas begin. Will we see it coming next time? The difference is that, unlike them, we have a narrow window of agency. The geological record shows that impacts and comet encounters are part of Earth's story. They are not punishments, not fate, but statistics. The black mats, the ice scars, the drowned coasts all say, this has happened. It will happen again. Whether the next chapter is our undoing or our first successful dodge depends on whether we take those lessons seriously enough, while the sky above us still looks ordinary. When we talk about the Younger Dryas or the Great Floods, it's easy to keep them safely back then, cordoned off behind thousands of years. Rocks remember, ice remembers. But do we? Not in conscious detail. Yet some researchers are beginning to ask a more unsettling question. Can an event that ended 12 millennia ago still be vibrating faintly in our bodies and our cultures right now? On the biological side, the idea starts with epigenetics. Our DNA sequence is relatively fixed, but how that DNA is used, what genes turn on or off, can be influenced by environment, especially by extreme stress. Chemical tags, like methyl groups attached to DNA or modifications to histone proteins around which DNA is wound, can make certain genes more or less active. Crucially, some of these changes seem capable of slipping past the usual reset that happens when sperm and egg fuse, persisting into the next generation. Studies in mice and humans have begun to sketch the outlines of transgenerational echoes. Offspring of animals exposed to famine, toxins, or fear conditioning sometimes show altered stress responses or metabolic profiles, despite never encountering those triggers themselves. In people, descendants of individuals who lived through the Dutch hunger winter at the end of World War II show subtle differences in markers related to growth and glucose regulation. Children of Holocaust survivors, in some studies, exhibit distinct patterns of stress-related hormone regulation. These findings are early, contested, and easily overblown. Epigenetics is not Lamarckian magic. We are not neatly inheriting memories. Yet the core idea that extreme stress at a population level can leave faint biochemical fingerprints in descendants is gaining cautious traction. If that can happen over a few generations, what about dozens? Hundreds? Now scale up in your mind. Imagine clan after clan living through years where winters suddenly lengthen, food fails, fires rage, water invades, the sky darkens strangely. Infancy and childhood, the most sensitive windows for shaping stress systems, become periods of chronic uncertainty. Those who survive may be those whose bodies err on the side of vigilance, quicker to trigger fight or flight, more wary of environmental cues. If such tendencies were reinforced culturally and nudged biologically, a style of nervous system might spread, a baseline of unease tuned to a world that once turned hostile without warning. We can't, at our current level of evidence, point to a specific methyl group on a specific gene and say, there, that belongs to the Younger Dryas. The signal, if it exists, has been diluted by countless later famines, wars, plagues. But the question itself shifts the frame. The cataclysm isn't just a layer in Greenland's ice. It might be a subtle bias in how easily our species startles, how much we crave control, how we react to thunder. Culture, more than DNA, is where long echoes are easiest to see. Human societies encode danger in rituals and taboos. Don't build here. That hill is sacred. Don't eat this animal. It offends the spirits. Don't go out on the water when the moon is a certain way. To a modern eye, these can look arbitrary or superstitious. Yet often, when anthropologists dig deeper, they find practical wisdom hiding behind the rules. Floodplains that have drowned settlements before, shellfish that are toxic in warm months, fault lines that have shaken the ground. Flood myths are an obvious case. As we've seen, hundreds of cultures around the world have stories of overwhelming water, few survivors, and a new beginning. Even if the details have morphed beyond recognition, the core message, water can rise higher than you think, higher than your grandparents think, is preserved. Telling such a story to every new generation is a way of keeping a low-frequency alarm bell ringing, a cultural epigenetic mark. Beware the sea. Respect the river. Do not assume the ground you stand on is forever dry. Consider our phobias. Fear of deep water, of heights, of storms, of the dark. These are near universal in children, often subsiding with experience. Evolutionary psychologists usually explain them in broad terms. It was beneficial, across millions of years, to be cautious around drowning, falling, and predators that hunt at night. But mass catastrophes could sharpen those inheritances. If entire communities once watched familiar coastlines vanish or saw generation after generation, storm surges chew away their world, those with an extra sliver of wariness around shorelines might have been more likely to survive and keep their children alive. At night, many people report a flicker of unease under clear, star-filled skies, especially in isolated places. It can feel like awe, or like being watched. That may be simple awareness of vulnerability in the open. Or it may be a distant reverberation of times when the stars did more than twinkle, when streaks of fire stitched across this same vault and exploded with the force of bombs. We do not consciously connect a meteor shower to a tale our ancestors told 10,000 years ago. Yet the stories we still tell, of falling stars that grant wishes, of comets as omens, suggest that the sky's behavior has long been linked, in our symbolic vocabulary, to sudden change. Even in children's tales and animations, the end of the world is a surprisingly common theme. Floods, ice, comet impacts repackaged in friendly colors. We turn apocalypse into bedtime stories, nightmares into play. That might be pure coincidence of narrative taste. Or it might be another way a species that has lived through near erasure rehearses, in imagination, the thing it fears most, trying to dull the edge by telling it first. None of this is proof. It is a pattern of hints. Biochemical studies of inherited stress, anthropological work on taboos as hazard maps, comparative mythology tracing flood motifs across continents. Together, they invite us to see the Younger Dryas and its kind not just as geological curiosities, but as formative events in our species' inner life. The ice remembers temperatures and dust. The ground remembers water and fire. We may remember too, not in words and dates, but in how quickly our hearts race at thunder, in the stories we compulsively retell, in the deep, half-articulated sense that stability is precious and fragile, because once it wasn't there. In a darkened control room atop a mountain, a bank of monitors glows with images from a telescope aimed at the same sky that once terrified our ancestors. On one screen, a faint streak betrays the motion of a near-Earth asteroid against starfield static. On another, the cratered face of the moon is rendered in razor-sharp detail. Outside, The constellations still trace their old patterns: Orion, Scorpius, the Pleiades. But inside, the labels have changed. Protoplanetary disks, Kuiper belt objects, trans-Neptunian binaries. The dragons and storm gods are gone. The awe is not. Modern astronomy began as a quiet rebellion against myth. Telescopes revealed that Jupiter was a world with moons, not a wandering star. The Milky Way broke into countless suns. Comets followed calculable paths. Bit by bit, the heavens lost their divine opacity and became a physical place. Yet, as our instruments grew more powerful, they began to show something the early rationalists did not expect. That the old terror, that the sky can strike, was, at its core, correct. Look first at the moon. To the naked eye, it is a pale disk with dark blotches. Through a good telescope, it becomes a graveyard. Craters overlap craters, some neat and sharp, others softened by age. Rays of ejected material streak outward from younger impacts. Vast basins, once thought to be seas, are now understood as the scars of titanic collisions in the early solar system. There's no weather there to erode or hide them. Each crater is a frozen memory of something that hit hard enough to melt rock. Turn the telescope to Mars, Mercury, the moons of Jupiter and Saturn. The story repeats. Pitted, battered, shrapnel-blasted worlds. Only Earth and a few other bodies with active geology and atmospheres look, at first glance, smooth. But we now know that is a trick of erosion and plate tectonics, not an absence of impacts. Radar and gravity mapping have uncovered buried craters beneath our own continents and oceans. The 180-kilometer Chicxulub crater under the Yucatan, linked to the dinosaur-killing impact, was only definitively mapped in the late 20th century, its circular gravity anomaly and shocked rock finally matching what iridium layers and fossil gaps had implied. Zoom out further, to orbiters around other planets. The Messenger mission to Mercury, the Lunar Reconnaissance Orbiter, Mars Global Surveyor. All have returned images showing that, in the early days of the solar system, impacts were unimaginably frequent and violent. Entire hemispheres are carpeted with overlapping blast marks. Our world went through the same storm, we just healed differently. Then, through surveys scanning the depths of space, we see newborn planetary systems forming in dusty disks around young stars. In those disks, clumps of material collide and merge, grow and scatter. Simulations show that building planets is a messy process, full of near misses, glancing blows, and catastrophic smashes. Giant impacts likely helped create our moon, tilt Uranus on its side, strip Mars of much of its atmosphere. The cosmos, it turns out, is not a stately clock, but a rough neighborhood where gravity slings rocks at high speeds and stability is something won, not given. As we map all this, something shifts in our relationship with ancient stories. When the Sumerians imagined gods battling in the heavens, splitting primordial dragons to form sky and earth, they were mythologizing a real phase of cosmic history. One we now glimpse in telescope images of distant gas clouds lit by newborn stars and carved by stellar winds. When later peoples told of fire from heaven and days of darkness, they were, in crude metaphor, describing what a major impact or volcanic eruption might look like on the ground. With each crater we date, each iridium spike we analyze, we find more episodes where the sky did not behave like a ceiling, but like a throwing arm. Modern astronomy, then, is not a total break with ancient sky watching so much as its continuation with better tools and a stricter rule book. Priest astronomers on ziggurats tracked Venus and eclipses, trying to anticipate omens. We tracked near-Earth objects and sunspots, trying to anticipate threats. They built alignments in stone. We build arrays of CCD sensors and space telescopes. The underlying impulse, to turn helpless awe into actionable understanding, is the same. there is still dread. When we discover a new asteroid and, after initial orbit calculations, assign it a small but non-zero probability of impact decades hence, a familiar chill runs through control rooms. When solar physicists model coronal mass ejections that could, in a bad alignment, fry our electrical infrastructure, the old sense of vulnerability resurfaces. The terms have changed, Carrington events, Torino scales, but emotionally, we are back at the campfire, watching strange lights in the sky and wondering what they portend. At the same time, there is a new note in the ancient song: agency. We are no longer confined to watching. Spacecraft fly to comets, drill into asteroids, orbit distant worlds. The same telescopes that show us craters also give us the data needed to deflect future impactors. In understanding the mechanics behind what our ancestors personified as God's anger, we gain, if not mastery, at least the possibility of negotiation, not through sacrifice, but through engineering. Still, the visceral reaction when we see certain images, the Chicxulub core sample, dark and shocked, the global ejecta layer at the KPG boundary, the scarred face of a Jovian moon, is one our ancestors would recognize. A mixture of awe and horror at the realization that we live on a target. Our telescopes and probes, for all their sophistication, are in this sense just the latest chapter in an unbroken human project. To read the sky for signs of its moods, to decode its cycles, and above all, to avoid being surprised the way we were once surprised at the end of the Ice Age. We have traded myths of dragons for models of impact probabilities, replaced omens with orbital elements. But when we gather in dark rooms to watch live feeds from spacecraft darting past comets, or hold our breath as a kinetic impactor slams into a distant rock, we are still doing what those first storytellers did, sitting beneath a vast, indifferent universe, telling ourselves that if we pay close attention, if we name the forces and learn their ways, we might this time see the next blow coming in time to duck. If the Younger Dryas was a hard reset, the obvious question is, what, if anything, did we manage to save when the screen went dark? Fear, yes. Flood stories, yes. But is it possible that something more concrete slipped through? A thin thread of knowledge from the world before the Great Melt, carried by a few survivors into the New Age. We begin with puzzles. In multiple early civilizations, sophisticated understanding of geometry and the sky appears with startling abruptness. The builders of megalithic sites in Britain and Brittany lay out circles and ellipses with precision, implying knowledge of Pythagorean triples long before Pythagoras. The pyramid builders of Egypt align their colossal monuments to true north with an accuracy difficult to achieve without careful stellar observations. Sumerians work in Base 60, a mathematical system exquisitely suited to dividing circles and time, and seem to know enough about celestial cycles to derive reasonably accurate lengths for the year and certain planetary periods. Across the ocean, the Maya and their predecessors track Venus and eclipse cycles over centuries, building interlocking calendars whose long counts span back into mythic prehistory. At Gobekli Tepe, in that earliest of known temple complexes, hunters who have not yet adopted full agriculture can nonetheless move multi-ton stones and carve complex reliefs in abstract, organized compositions. None of this proves high technology or lost satellites. Stone and sky are old teachers, but the speed and coordination with which some of these skills appear raise eyebrows. Then there are the civilizing heroes. Many cultures remember figures who arrive after a disaster bearing gifts of knowledge. In Mesopotamia, the Apkallu, semi-divine sages, are said to have come from the sea in antediluvian times, teaching humans the arts of writing, metallurgy, and law. In Sumerian lists, one such sage appears with each pre-flood king, as if advanced wisdom is paired with rulership from the very beginning. After the flood, these beings retreat. Their post-deluge counterparts are mere human scholars, as if something has been lost. In Mesoamerica, Quetzalcoatl sometimes appears as a bearded, robed figure from the east who brings maize, calendars, and ceremonial order. In Andean legends, Viracocha emerges from Lake Titicaca after a dark age, teaching people how to build and farm before walking off over the sea. In Egyptian lore, Thoth is the divine scribe who invents writing and measures. And there are hints of a time before the Nile's familiar regime, when gods like Osiris brought agriculture and law to a more chaotic land. Taken singly, each of these stories can be read as mythic allegory, culture personified, divine endorsement of existing elites, cosmic drama. Taken together, they begin to look like different cultures groping for a common idea, that after a catastrophe, a small number of people, or beings symbolizing people, preserved core techniques and reseeded civilization. What might such an inheritance have looked like in practice? Not blueprints for airplanes or computers, but rules of thumb and patterns. How to read the seasons from the stars, how to track lunar cycles, how to lay out right angles with simple ropes, how to move heavy stones with levers and teams, which plants can be domesticated, how to store grain safely, how to encode agreements and debts in marks on clay or knots in cords. A group that carried even a portion of that toolkit into a shattered post-flood landscape would seem like magicians to their neighbors. It is tempting at this point to slide into fantasy, to conjure an Ice Age super-civilization with global reach and technology rivaling our own, lost entirely, save for a few hints in stone. But the archaeological record, as far as we currently see it, does not support skyscrapers swallowed whole or metal foundries melting under waves. What it does support is the existence of capable, observant humans living in complex communities long before the classical cradles of civilization. A network of cultures whose most developed expressions were concentrated along coastlines, later drowned. The cadre of knowledge keepers model does not require secret Atlantean archives. It asks us to imagine something both humbler and more extraordinary. A few bands or lineages, scattered by catastrophe, who prioritized memory. While others focused, understandably, on immediate survival, these groups also maintained songs, notches, diagrams, and rituals that preserved abstract patterns. The length of the year, the sequence of certain constellations, techniques for building with stone, principles of fairness encoded in proto-laws. When climates settled and populations regrew, they were positioned to become the nuclei of new centers. Evidence for such intermediaries is circumstantial. Sudden appearances of urban planning expertise, mythic attributions of knowledge to outsiders or those from before, megaliths that seem to emerge fully formed rather than evolving from cruder predecessors. None of this proves a hidden inheritance. But it does suggest that we should be cautious about assuming every wheel was reinvented in isolation, especially in a world where coast-hopping seafarers could have carried ideas as easily as shells. Ultimately, though, the deepest legacy from before the flood may not be any particular technique. Wheat can be rediscovered, stones requarried, stars recharted. What is harder to conjure from nothing is the attitude that such things are worth knowing, that the patterns in nature are intelligible, that understanding them grants power, and that this power can mean the difference between perishing and enduring when the planet shifts. That attitude, call it curiosity sharpened by fear, is everywhere in the early Holocene, in the patient sky watchers on ziggurats, in the careful alignments of megaliths, in the decision to scratch tallies into bone instead of trusting just to memory. It is the through line connecting someone who first noticed that a particular star rises just before the flood season to someone who today writes code for an asteroid tracking telescope. Whether or not a few ancient sages deliberately carried knowledge across the Younger Dryas Gulf, we are their heirs whenever we look at a dangerous universe and respond not only with myth or prayer, but with measurement and shared learning. The hidden inheritance, in that sense, is less a stash of secrets than a stance. That the cosmos, however capricious, can be studied. That catastrophe is not just punishment, but event. And that in the long run, our best shelter against the next blow is not a bigger wall or a higher hill, but a deeper understanding of how the sky and sea without warning once remade our world. The sky's on fire. Not from war, not from volcanoes, but from a rain of stars turned weapons, streaking across the firmament as oceans rise in walls of black water and whole continents vanish in a single night. Somewhere on a shrinking shore, a small band of survivors watches the world they knew die, clutching not gold or weapons, but stories. Tonight on Moonlight Science, we follow those stories back to their source, to the night the last ice age ended, when a real 12,000-year flood carved itself into the bones of our planet and into the myths that still haunt us. This is the tale of a forgotten civilization standing on the edge of annihilation, the celestial crossfire that erased them, and the memory they smuggled into the future, disguised as legends of gods, arcs, and world-ending deluges. And there is one last secret, buried not in ice or stone, but in us, a legacy from that night of fire and water that we still carry without remembering. Until now. We can see that night more clearly now, not as a single, simple act of divine anger, but as a chain of physics and chance. A giant, fragile comet wandered inward, broke apart, and seeded the Taurus region of the sky with rubble. One bad crossing later, Earth plowed through a dense swarm of its fragments. In the upper atmosphere, those pieces became artificial suns, airbursts hotter than anything our ancestors had words for. Fire poured down over forests and ice. Megafloods erupted from shattered dams of glacial meltwater. Soot and dust veiled the sun. Temperatures plunged. What had been a slow thaw out of the last ice age whipped back toward winter in a human lifetime. The ice remembered that flip as a spike in isotopes and platinum. The soil marked it as a black mat laced with nanodiamonds and melted spherules. The bones of mammoths and giant sloths ended abruptly beneath that dark band. People remembered it as a time when the gods sent a flood, when the sun hid, when stars fell like arrows. For 1,000 years, the Younger Dryas gripped the climate. Harsher winters, altered storms, vanished giants. Then, just as suddenly, the cold released. Glaciers retreated for good. Seas surged inland. In that second transformation, the Holocene, the only world our histories know, was born. Out of the wreckage, humans did what we do. We adapted, and we told stories about it. We watched rivers reverse and valleys drown, and we spun those terrors into myths of arcs and chosen survivors. Utnapishtim, Noah, Manu, Deucalion, faces of one archetype. The person who saw the change coming, saved a fragment of the old world, and carried memory into the new. We watched mammoths disappear and seasons betray us, and we turned that guilt and bafflement into tales of angry storm gods and sea lords, into moral narratives where floods came not as random insults from space, but as verdicts on human noise, violence, and excess. We raised stones to mark the sky, At Gobekli Tepe, hunter-gatherers carved pillars and animals as if rebuilding a cosmos they half remembered from before the freeze. Along coasts now underwater, early villages and perhaps denser settlements hugged shorelines that would later drown, feeding the rumors of Atlantis-like lands swallowed in a single day and night. In the Fertile Crescent, amid lingering anxiety that the world could tilt again, people hedged against chaos by planting fields, penning goats, and stacking grain. If the sky can fall, at least let the granary stand. Cities rose with walls and towers, reenacting old patterns in new mud brick, turning the raw memory of exposure into stone and law. As millennia passed, the catastrophe blurred. What had been testimony became myth, then theology, then background. The gods of storm and sea kept their portfolios long after most had forgotten why they were feared. Flood stories were copied onto tablets and into scriptures, their timelines stretched, their causes moralized. The original comet faded, but its debris stream remained as the Taurid meteor river, still intersecting our orbit twice a year. An unseen reminder that the event 12,800 years ago was likely one bad encounter in a repeating celestial schedule. In our own age, the fear resurfaced wearing modern clothes. Nibiru, once a precise Babylonian term for a crossing point in the sky, was reinvented as a rogue planet destined to bring a new deluge. The Mayan calendar's turnover in 2012, a simple cycle reset, was recast as an appointment with annihilation. These fantasies flourished not because the data supported them, but because an old intuition that the sky can suddenly become hostile found an easy hook. When we stripped away the fiction with telescopes and surveys, the dread didn't vanish. It simply refocused. Today, we can trace real threats. We've mapped impact basins on the Moon and Mars, found the Chicxulub crater that ended the dinosaurs, and read platinum spikes and soot in the Younger Dryas boundary. We've cataloged most kilometer-scale near-Earth asteroids and begun, haltingly, to track the smaller ones that could still level a city. We've even nudged a distant rock, Dimorphos, off its path with a kinetic impactor, our first experimental answer to the problem that tormented those who watched Tunguska and Chelyabinsk explode overhead with no warning and no options. Alongside that hardware, we're beginning to appreciate softer inheritances. Epigenetic studies hint that trauma can leave faint biochemical echoes in descendants. Anthropology shows how taboos and myths act as hazard maps, telling us where not to build, what not to eat, when not to sail. Comparative mythology reveals flood motifs and fire from heaven tales scattered like shards across cultures. None of this proves that a specific Younger Dryas night is coded in our genes. But it suggests that the end of the Ice Age was not only a geological event. It was a formative wound in our species' nervous system. Seen together, the Younger Dryas impact hypothesis, the black mat, the drowned coasts, the megaliths, the flood gods, the Atlantean dreams, the Nibiru scares, and our present asteroid surveys all tell one story. Our world is not guaranteed. The relative calm of the last 11,500 years, the Holocene stability that cradled agriculture, cities, and everything we call civilization, is not the baseline state of Earth, but a lucky plateau between convulsions. We live, as our distant ancestors did, in a cosmic shooting gallery. The difference is that we no longer have to face it blind. That is the quiet revolution. Those first witnesses of the sky on fire had only memory and metaphor. They turned trauma into myth and myth into ritual, hoping that by telling the story they could ward off its return. We have inherited their fear, but we've added something new. Instruments, models, archives shared around the globe in real time. We can scan the Taurid stream instead of just fearing falling stars. We can model how ice sheets respond to warming instead of treating rising seas as inscrutable wrath. We can, in principle, see the next big rock coming early enough to push it aside. None of this makes us invulnerable. Unknown objects still lurk. Our own actions, carbon emissions, ecological overreach, are driving changes as profound, in their way, as some past natural cataclysms. The lesson of the end of the Ice Age is not that everything is doom. It is that everything is contingent. Worlds end when physics demands it, not when our stories say they should. Our responsibility is to stop confusing the two. The night the Ice Age ended was, for those who lived it, the end of everything. For us, it can be something else. A beginning of clarity. In the soot layer and the ice bubbles, in the sagas of floods and the stones aligned to solstices, we can read a message from people who had no idea we would exist. The universe can change faster than you think. Pay attention, remember. The true legacy of that 12,000-year-old flood, then, is not perpetual terror of the sky. It is the obligation. Now that we finally understand a little of what happened, to act on that understanding. To treat knowledge as the most sacred ark we've ever built. To use it not to inflate new myths of phantom planets, but to quietly, stubbornly reduce the odds that any future band of humans will have to stand on a shrinking shore, watching their world drown with nothing but stories in their hands.